computer. Nice. Okay, today we'll discuss, sorry, yesterday we discussed single agent flow. Today we'll discuss multi-agent systems and memory. Three prototypes. Today we'll go slow. And what we'll do is we'll start with memory and then we go into multi-agent stuff. So memory is again the hottest topic, or rather, to be honest, the easiest topic. Like again, memory is complex, I agree, but everybody feels that memory is something that they can build because it's the thing that comes closest to database and extracting information, like the kind of CRUDs that we have been building. So that's why you see so many memory startups, context layer startups, people building their own memory have come in. Because this is where you this is like your classic API that you build that talks, fetches the relevant information and serves it. Right? So now when what's like different, like memory, one of the stuff that we use, which is memory, is nothing but like your context that we add, that we keep adding to your conversation chat. That is nothing but your in context memory, right? Because that is part of your context window. Now, given it is part of your context window, it does not require any retrieval that you would want to get out of it. Like it's not an external system from which you are extracting something. It's literally part of the system. It's literally part of the chat. So one thing that we have been kind of touching upon is if your context becomes big, your LLM starts to struggle with lost in the middle problem here. So most attention is given to the beginning of the stuff, beginning of the context and end of the context. At the middle, things suffocate, right? That's always a problem. So that's why you typically do not want your context to become very massive and just keep what's required in your context window. But it has its downside as well, as we kind of touched upon it, where if you are having like extremely large context window, loss in the middle is one of the problem. Cost is another, because now you are paying for all the tokens because every LLM call is like full context being passed there. Now, if you're compressing it or whatever you're doing with that memory, if you don't put it, then your prompt caching takes a hit. Then your caching token consumption reduces and then you pay more. So now that's why it's a very tricky problem to deal with. Now, how should you deal with it? Again, the answer is it depends, but depends on what scenarios is what we'll focus on in a bunch of prototypes and the systems that we discuss later. Right? But first type of memory is your current context window that you have filled with uh, everything you put, the files that you load, the fragments of your snippets of the code that you load, or the instructions that you give. All of this parts of is part of your in context memory. Now, when this becomes big, of course, there are strategies to evict, summarize, and all. We'll discuss it in some time. Second is external key value store as a memory. This is where you classically use your Redises of the world, your DynamoDBs of the world to hold. Now you can choose to hold your entire conversation as is, or you could or you could extract facts and decisions and important aspects and store it externally. But the whole idea is that when it grows very big, you can store everything in Excel system, and it's a classic trade-off that you pick what's most important, what's most relevant, like how we discussed BM25 and basically cosine similarity based lookup, or basically your vector database HNSW part. You retrieve it and that becomes part of your context, like that becomes your next LLM call. Okay, now who decides what to retrieve and how to retrieve and what's relevant? Again, it depends on your use case, but I'll take two examples. First is, it's not that it's always going to be a semantic lookup or a semantic retrieval that you are doing. Sometimes the information like what was the rate limit of this customer, don't think this as a prompt, think of this as a requirement that you want to bring in. Now, this could be in your agentic loop, it could be a tool call which says, hey, I want to retrieve the rate limit for this customer due to whatever reason, right? And then there is a tool call which is written. The tool call goes, makes a call, literally creates that key, that user ID, rate limit. Again, you have to provide it in the tool description, what key format it is and how you get that information. It goes there, makes a call, gets the response and adds it to your context, right? That is what you are doing. So now here information is not just with respect to chat that you are doing or your agentic flow that you are doing. This information is also could be user configuration, user preferences, or some past historical relevant chats or some key decisions that you think should have been persisted, right, over a long chat. right? All of that you can store externally, but the whole trade-off is your good part is your context is small, your working context is small, but the bad thing is you have to retrieve it, which means your key needs to be very deterministic in way, or the query that you are firing or the MCP tool that you're exposing needs to be very deterministic in way so that you can fetch the relevant information, which means your tool definition, input schema and all becomes very critical. Now, what are these external systems? Although I took examples of Redis DynamoDB, but think of your Elasticsearch also as this. Like not just like don't just think of external key value memory as vector. Any database that supports vector also is an external memory, but we'll cover this in vector memory, which is your semantic lookup. But external key value store is like named facts. Given this, give me this. Right? That is our external key value store. Now, also, it need not be just key value store. You can make it anything, but key value store is most popular because you're typically looking for pointed stuff. Hey, I want A, B, C. Let me get that information by doing a multi-get, etc., and proceed. Right? So this is where your, again, if you look at it, this is where a classic system design typically comes in, where how much of database to provision, how do you make sure availability of it, how do you decide key patterns, now are you doing range lookup or pointed lookup, etc., you have to be aware of that. Then comes Elastic. If you are looking Elasticsearch to do keyword based lookup, which is your BM25 or TF-IDFs of the world, there you need to know what analyzer you are choosing, how you are querying the data, how your Elasticsearch query is being formed, what kind of data you need, what your ranking strategy is, and then what your, if you are using uh, uh, LL rank, ML rank, whatever that thing is that does re-ranking using a deep learning algorithm within Elasticsearch. I forgot the name of it. If you're doing that, then that entire feedback loop needs to be. So this is your entire information retrieval as a domain. Right? These are external key value memory, external memory that you are stored or that you are holding. Then comes your most popular nowadays, which is your vector memory, where you're essentially doing a semantic lookup. Now here, I kept these two separate, which is external key value store and vector, because I wanted to emphasize on configurations, on preferences, on graphs that we are trying to fetch. And then cosine similarity. Now there are databases which has merged both of these two seamlessly. Like Elasticsearch also supports vector lookups, or your Postgres supports your transactional queries and your selects and your wheres and indexes, etc., and also supports vector, like through a PG vector extension, it also supports vector lookups. But this is where the whole idea is, your embedding of your document or your query determines what is more relevant to you, right? Similar to what we discussed in previous weeks. Right? So this is where you're doing semantic lookup. But again, lines are now becoming blurry because every database is a vector database, but you can treat them separately so that you are not just always doing a semantic lookup. My point here is, don't treat that every RAG solution or everything that I'm building has to just blindly go into a vector database and just retrieve it and that's all you need. Always remember, treat what you like. Again, think, look at your look at a problem statement, understand the flow, and then decide what you would want to do. Next up is now getting closer to how human brain works, which is episodic memory. Fancy word. Think of episodic memory as important facts, important decisions is what you're trying to hold, like sequence of events that happened, right? That is an episode that has happened, and you're extracting from your conversation this stuff. Again, you use LLM to extract this information, and then you put it into, again, this episodic memory can be stored in your Redis, your DynamoDBs, or your Postgres of the world, but or your graph database, depending on how you choose to query it. Right? So these are key thing is you are extracting the key facts out of it or key events out of it, and then you're storing it somewhere, making it easy for you to retrieve. Now, episodic memory is also a good way to summarize the information. Like for example, if a chat has happened, it has gone really big. Now you want to summarize it. Either you make an LLM call, say, hey, whatever is there is summarize it, or you can write a more sophisticated prompt and say that, hey, this is the conversation history that I have. Please make sure you are logging or you are summarizing it by not losing A, B, C, which is your key facts, key events, key decisions you made, etc., etc., etc. And that is a good summarization prompt rather than just blindly saying it. Now, this is again, summarization is not the only use case, but imagine episodic memory is like, hey, I used to like pizza, now I like burger. Right? That is also a key change in preference because of some event that happened, that you went to a place, you tried burger for the first time and you loved it. So this is what you have to understand. Again, there is no generic way. You have to look at your system and see, given the system, are there any episodic traits that I could extract out of it? Are there any events, insights, decisions that I could extract out of it, which I certainly don't want to lose? You can convert it into embeddings if it is verbose text, but very likely you would be extracting it as facts, and very likely you would be querying it as a structured data rather than just a semantic lookup, because for that you have vector memory where you have verbose of like high verbosity text, incidents, etc., that you are trying to retrieve. But episodic memory in a gist is more about the key facts, the key events that you would want to extract. Now, let's dig deeper into in context memory, because this is the most important one, because that directly impacts your cost. Now, your key or your working memory is with your main context window that you have. That is the most important thing for your agent, because what you have in the context is what's getting passed into the prompt. Now, that has limited capacity, right? You may have 1 million token, 2 million token. Remember the old days where you have 100,000 tokens as limit, right? So 1 million, 2 million is 1 million is what most people use, but again, it's still for some model, it's still even lesser. So it does not mean, as I said, it does not mean if your context window is 1 million and if you pass 1 million tokens to it, it does not mean that every token gets equal attention. I'm reiterating, remember this, there's a lost in the middle problem. Right? First thing gets more attention, last thing gets more attention. There's a very interesting paper which says if you copy paste your entire prompt twice, it gives you better result. Literally, like by just doing nothing, you just copy paste your prompt twice and you'll get a better result. So it's like kind of acting as a forcing function. It is giving your task enough attention that it deserved in the first place. Right? Okay. So now, what is the challenge with context window? First, it's limited. That's a constraining factor. Second is what you put into context. You put your system prompt. Yesterday we saw with paper how big our system prompt became. Right? If not, when you're reading the entire paper and putting it into the context, every iteration of your next prompt or next chat, all of that is going into the context. Another thing that goes into context is tool definitions that we saw. And we saw how verbose our tool description was and how non-ambiguous we had to make. Now all of that goes to your context. Then goes your user prompts, which is things entered by your user. Then goes even responses that your LLM generated or your user responded to an LLM query goes into your context. Then your file content. Yesterday we saw how the code that was written was part of the context. It fixed it, added it, etc. Then you have intermediate observations. This is what your reasoning loop that we spoke about is added. That the thinking of your model is outputted as a text, which is again added as a context in the chat. Right? Okay. Now, given this is a fundamental thing that your agent is working with, the only thing that your agent can work with, how do we manage it? Now, there is no one right way to do it. It's not always summarization. So there are different strategies to deal with it. First one is eviction. Where, for example, if your context window has become really big, you can choose to remove the content. But as we kind of briefly touched upon it yesterday, which content to remove, we don't know. And imagine you remove the oldest content, then your prompt caching takes a hit. That's another problem, right? So then you have to be very mindful of what you are evicting and why you are evicting. Some examples. So for example, once the decision is taken, any reasoning step that you took to reach to that decision can be removed. Or if you have verbose tool outputs, that could be removed. One simple example of that we kind of saw yesterday was like your research paper stuff. Either we put your entire paper into context, then it decided what all section it had to read, or once that is done, that step, from there we extracted what are the sections, and then this step finished, we hold it into an external storage. Now this entire context can be removed and evicted because now we don't need it. So you decide that in this single agent loop that you have, you're first reading the paper, give full paper, extract the sections and the text of it. Once that job is done, you remove everything from the context and just add that one simple bit to it. Right? That makes your life simple. So again, like always, there is no one right way to do it, but you decide what is something you don't need in the context. It could be your subtask whose result is Z. For example, your calculation is done, that 0.1% population of India, wala calculation that we did. Imagine that calculation is done. Now we have the answer. Now we don't need the tool response. We can choose to remove the tool response because our job for that is done. Now imagine the complexity of you tracking what is important and what is not. Because the biggest problem when you're trying to evict something from your working memory, which is your context window, which is your conversation, is we don't know if at step 8 we would need the output of step 3. We like output of step 3 at step 15. So we are at step 8. Step 3 outputted something, but we don't know in future step because we only have visibility to the 8th step. We don't know if in any of the future step I would need output of step 3. So until and unless you are very sure, don't evict it. And once you're evicting it, that's why what your reasoning traces were, you can choose to evict once the job is done. You could choose to evict subtask result once the job is done. Now imagine the complexity you need to build around it to decide what should I remove, what should I not. Right? Okay. One specific example of this is imagine you're building a LLM based trading agent. Nobody should build it, but imagine you're building this. Now imagine in context window, the past trades of a particular stocks are added. Now you don't want your LLM to act on your outdated signals. So as and when you keep moving ahead, you keep evicting stuff from a context window because you would want to deal with your latest signals that you're getting and not the outdated ones. Again, a trivial example, but you see the reason for you to remove it. Or if you take example of a coding agent, where you have a long running coding agent, then you're kind of doing a massive refactoring. Once a particular file is refactored and it's working fine, you can choose to remove it from your context. You don't need it anymore. Right? So what you remove and how you remove completely depends on your use case. There is no one right answer. But hence, you need to understand your use case really, really, really well. And don't just blindly. That's why my job here is to serve the buffet and tell you places where you need it. Now, what you choose and how you choose is something that depends on your use case. And now that you see how tricky evictions can get, hence now here think of it that why people rely on summarization more. Because it is pretty general purpose that way. Hey, once I summarize the result, I make sure I capture all the key information, but there is still risk of it being lossy. It removed or it skipped something which was more important. Let's say a output of a tool call that you need later. So, but it's usually safer to do it and very general purposey. Right? So that's why you see a lot of people by default inching towards summarization, but you can choose to do uh, eviction of things that you are sure of that you would not be needing. Right? So if you have a very deterministic workflow that you have built, then you know that once this step is executed. So I'll give a concrete example. One of the agents that we are building at Workplace has 15 steps. And after first 5 steps, all it matters to us is the output of that 5th step. After that, we don't need that first 5 step. So we just got rid of it. And that helped us save the cost. Very simple example. So that's why if you have an idea of what your use case looks like, if you have an idea how your chat is going to, or not just chat, it's not just human who is chatting, but if you know that this agentic loop, this is how it's going to behave, until this point I would not need this thing later, then you can choose to remove it. So that is where imagine how the implementation, you have a list of strings, which is your chat, and for each one, instead of just string, make it a dictionary, and each one you tag it with what it is doing. If you have a very deterministic agentic workflow or loop that you're trying to build over here. Now that we know why summarization is so general purpose and important, so here the whole idea is it takes your older messages, compresses it, it tries to retain the summary, but this is always going to be lossy, right? And it's slow because it involves an LLM call. But where is it okay? It's okay where you want to first not let your context window explode to save cost and like not hallucinate, etc., etc. But more importantly, practical examples of it is, let's say your like your basically customer support chatbot, where the conversation has flown a lot, and because it's human and AI kind of talking like human language, there is not much decisions that are being taken. You could then summarize it and just replace our entire context with that one and then let the chat continue. Because in most cases, you are just doing chit chat or like humanish chit chat, and you could save yourself some tokens. Then another is your legal discovery system, where you are hunting for a case which which supports your argument. Imagine you are a lawyer and you're fighting a case. And for that case, for you to prepare for that case, you're finding a supportive argument, a similar case in which court gave a certain kind of order. Once that is discovered, let's say you have multiple steps into it, and let's say one of the steps found the most relevant one, and now it will continue to hunt. Once that most relevant one is found, you can remove everything from it, or you could summarize and say, okay, this was a case, this is exactly what happened, this is the final verdict of it, and this is a supportive argument. So what it took as multiple steps to figure that out and reason about it gets summarized into this was a case, this when it happened, this was a party, this was the verdict, and this is a supporting argument that you could make. So this way you could, it seems lossy because now you have shrunk the text to a very small size or very small length, but what it did help you save is some tokens. Similarly, think of research assistant. When your research is done, there are a lot of exploratory questions that you ask it to summarize, it would summarize and just shorten your window. So, but key thing to remember is you should be okay with it being lossy, number one. For you to have a summary of whatever the chat has happened up until now is okay. It's good enough. That's number two. And you make sure you ask your prompt to capture the details. And those details are something that a prompt would not miss. So you may have like multiple loops to check that you are certainly not missed any if you are slightly unsure that your existing model might miss a few things. So then you trade off by making multiple calls, multiple LLM calls to summarize it so that you don't lose out on that information. Next part is you have eviction, you have summarization. Next part is moving to external storage, as we discussed, right? Where external could not just be another database, it could also be disk. Imagine you're just building something that just works on single machine, you can just dump it on the disk and make your life simple. Right. Now, here, for example, one of the most popular agent that does this is a coding agent. Your coding agent, you would have observed, creates temporary Python files or temporary test files to do this, to test your changes. These are nothing but your disk based. Like now when it needs to load it, it can load it, otherwise just storing it on the disk and like using it. Right. And then it just forgot to do it. There are many times where it forgets to delete it. But if you choose to, you want to delete it, you can delete it yourself or you can ask your agent to do it. But the idea is you can move this part and store it externally and then retrieve it. So either you evict. So this is similar to eviction. This is a strategy to evict, but it's not that now here, imagine this, you can extract key facts and store it in a structured format in a database, or you just take verbatim conversation and store it in the database, etc., etc. But the whole idea is you're managing your context window. You want to keep it simple. Now what I'll do is I'll take an example. After this, we'll take questions. I'll take an example of managing context window. So what I want to demonstrate with this is number one, how we know that we have hit this limit, where this code gets plugged in, what are the things that we do, and what are the repercussions that we see. Right? So I've injected or induced an artificial budget of 2000 tokens. I'm doing a 10-step DB migration plan, very simple, and I'm mocking a lot of tool outputs. I want to keep things very simple, but what I want to demonstrate is what do we gain and what do we lose by doing what we do. So let me share the screen. This is your working memory part. I will go to working memory code. Okay. Here. Okay. So here what I'm doing is I'm taking all the three strategies: eviction, summarization, and moving to external storage. I'm doing all three, right? And the whole idea is because my context is finite, I have to deal with that. So instructions. You are a senior database migration analyst. You receive investigation finding one step at a time. Analyze each step that you provided carefully. Note exact command, constraint, numbers, action items. You may be asked to recall any specific details later. So you see what kind of eval is what I'm building here. Is I will at the end of the summarizer or whatever, I'll ask it some questions about it, which should have been in context or not in context, depends on if your summarization is lossy or you did eviction and that information got lost. Now, what I did over here is here. So I have multiple steps which says I want to take schema snapshot, I have to do row count and volume. So and now these are like tool outputs that I have bonked. So this is step. This is the question that I have. Given this data, do this. And this is, imagine this is a mock tool output. Oh, it's too hot, okay? No. Okay. Then you have index inventory, then you have foreign key audits, then you do stored procedure audit, application query scan, etc. etc. Right? And here you have your development checklist. Now this is a multi-step operation that I'm doing. Now let's look at summarization, summarize history. How does the call gets invoked? Now here, if you look at this, I'm iterating this step by step, and I'm saying every summarize after every 5 steps, summarize what has happened. Replace the context and replace it with summary. It goes over here, it summarizes history, and then it replaces over here. Compress summary goes over here, and then it continues the chat. Messages here, there's a user message, it formed over here, step number 1 tool output, etc. etc. Here you get this output. Okay, now here I'm doing multiple phase. So phase 2, phase 1. Let's go to eviction. Okay, eviction. Now eviction, I'm doing simple sliding window based eviction that I'm trying to evict as per my context budget. So the moment my current tokens exceed my context budget, I evict, literally removing it from my context window. So this way, my messages are getting shortened. Here, look at this. My messages, let's say I popped bunch of stuff to be well within the limit. So I am hard coding it for now to be, where did it go? Summarize token, token count, context budget. So I'm artificially inducing the limit of 2000 tokens. Artificially, you can go till 1 million because it can go further, but I'm artificially limiting it so that I can show a demo. This is my token bar. Okay. Then we saw that we saw summarization. Now summarization, enumerate, summarize after, count tokens only, summarize history. Now look at the summarization prompt. Summarization prompt looks like this. Compress the following investigation step. Now here it's not a generic summarization that I wrote. It's specific to what my task was, so that I explicitly mention what is important for me and what is not important for me. Given what we are doing is a database migration, so what is important is exact commands, numbers, table names, constraint name, procedure, breaking changes, actionables. That is important to us, right? If I would have written generic, summarize this, very likely it would have skipped a lot of this important stuff. Hence, it's important to be very prescriptive in nature. How your doctor is prescriptive, it says one medicine morning, afternoon, evening. In afternoon, if there is no medicine, it writes X, 0, X. Right? It's very prescriptive and it exactly tells you which medicine to take and at what time. Very similar to this. Given my use case, I'm exactly telling what it needs to do and how. Now, I just added use extreme abbreviation, max 100 words. Every token must carry information. So I'm making it super dense. Now why I did it? Ideally I should not add this. But the reason I added this is to show it's lossy. I wanted to quickly convert to its lossy behavior. That's the only reason why I did it. Right? Okay. So summarization is done. And eviction, summarization, and external storage. So let's look at external storage. So for external storage, I'm holding this data now into ChromaDB. I'm using simple semantic lookup out of ChromaDB to find relevant part. That's it. That's not. So here the query goes, collection.query, query text, and results I would want, and I proceed further with that information. Role user, this is my user message that gets formed, which is the retrieved context from my ChromaDB that I get in results. Okay, let's run and see what it does. So when I run, I have some output, but at 7:30-ish something time, I ran this code first time and I got a mini heart attack. I got this 503. Voila, if Gemini is down, by the way, this is because Gemini was down for some time. I'm like, so which is why I always have output saved, and for this example I did not have any output. Oh, sorry, not this example. Working memory, I had one. Working memory here. I always save output. Always. So that if Gemini is down, I have my fallback plan ready. Right? Okay. Sorry. Now here it's running. By the way, all this fancy is just my terminal output skill that I've written. I write the code first, ask LLM to modify it, and then I ask it to apply my terminal output skill. So it renders it in a very beautiful way. So that's why my code looks very verbose, but it's just filled with this terminal output stuff. So that looks neat and clean. Okay. Now here what it did is we take the first phase here. Here, phase one, eviction. The moment it went over budget, here it went over budget, it evicted few things, right? And then it proceeded further. Then I have eviction sliding window. Now here we'll go ekdam niche. Hey, Gemini down again. 503. Hey, what's happening, Gemini? Okay, let it run. Oh, this one is still running. I suppose old output. Okay, here. So here, if you look at this, now what I'm doing is I given it 10 step stuff. I have token budget of 2000. I'm captured for each step how many tokens are getting consumed. Right? Now here you see the moment it crosses 2000, if I reduce it even further, it goes like, okay, before we go into that. Now if you look at it, here it's summarized. So here the summarization happened every fifth step. 250, 428, 591, 988, 1213. Because we ask it to summarize every fifth step, it's summarized. Then my context window shrunk and it increased further. Now here eviction, we were evicting when my budget hit 90% and then the eviction happened. Look at this increasing, and before the 10th step, because it hit the 90% of my total context budget, which is 2000, it triggered an eviction of historical message. The first message that it wrote, it would have evicted that message. And here, as and when we kept taking decisions, I kept putting it into ChromaDB. Now, when I try to fire a recall, for the first phase, which was eviction that we did, it could not find the result because eviction is lossy. Second, for summarization, it was lossy. It could not find. Now, what it tried to find, recall evict, it's outputting. Recall, check recall here. Answer. Chat, full chat, where did go question, eviction page, evict message, verification question. Here. Okay. Now, this is what the first step or the command in between it does. So I want to make sure that it doesn't lose that information. What is the exact rollback command and exact rollback time window that was documented in the initial schema analysis? Give the exact command string. So I just said the expected keywords I'm looking for are these. If it's not there, it's a problem. Right? So you could use this in your evals if you're trying to build something where a critical information in your system should not be lost. And given that you know what kind of system you are building, so that you know what is important for you, you try to capture that information and add eval so that if tomorrow someone changes your eviction strategy or rather your context management strategy, you have your evals in place to hunt that, to find that error for you. Right? So to report that error for you. Right? So this is what I tested, and here we see what works and what doesn't work. For external storage, it was retained because what it was looking for was already there in ChromaDB. It went, queried, got the thing, and it could output what we were looking for. Here it's there based on risk assessment, step final workflow. Okay, here, if you look at this model response, the exact rollback command documented in the initial schema analysis is this. The rollback time window is 4 hours post migration. Wall segments are purged after that. Again, it went through that. It could figure out a command and it's outputting. It will run. It will take some time. But what I wanted to certainly demonstrate is like different strategies to apply and where you would put your code. Now you can make one thing that I did is token budget. Here that I had token budget. Context budget. Now here the context budget that I added is here I'm just making my best guess. So ideally, it's not the exact like count tokens only. If I look at this here, if I would want to count tokens, I can do here. I'm making a call to model to count it. Again, it does not make a call to model. It's still internet call. It's still a network call that you are making, but you could still do it in a very simple way. You could just say my tokens is equal to number of words that I have in the text rather than having to make a network call to do that. Or you can use any local model that bakes in that information, that it gives you a rough estimate to do it, because not everything needs to be a network call to get exact precise information. Like imagine you are doing it for summarization, even if you do it like 100 tokens earlier, or if you're off by 200 tokens or 300 tokens, not the end of the world for you, right? So you could make a fair assumption and just work with that, right? Okay. Any questions up until this stage while this runs? It will take some time, but while it runs, any questions for around context management? Go ahead, Sumant.
Arpit, we discussed summarization, and LLM models also give something called compaction. Are these both same, different?
Summarization compaction is same.
And
So when you say LLM models gives you compaction, it is the Claude Claude Agent SDK is what you're talking about, right? Or your Claude code is what you're talking about. So
correct.
that is nothing but your infinite while loop that we say, and it picks up. Now there is a logic that is written in Claude. It says how do you compress it? How do you compact it, right? So that is a different branch on what strategy to apply, how to apply given the session. You can add a lot of smartness and go down the rabbit hole on how to best compact your working session, right? Pratik, I think you had a demo for that, right, where you made a network
I
call
did.
and saw it.
Yeah, I did. But also, so you already have that. Can you go back to your prompt that summarizes?
Yeah.
So you have given instructions on how to summarize. So
Yes.
assume Claude has the same thing. In addition to that, Claude also gives you an option to give your own prompt, which is you know the conversation that has happened. When you run /compact, you can add another prompt as a parameter there saying that always remember X and Y facts. So
Yes.
it also has this capability to inject your prompt. But by default, what Arpit has in the POC is what Claude does because it has a specific prompt that it will run whenever it tries to compact.
This one. So preserve only critical facts, exact
Yes.
commands, numbers, table names.
Yes.
So again, as I mentioned, that this is and I don't know, Claude, we could give our stuff to it. How do we give that, Pratik?
So it's /compact, and then it's not just /compact. So one way to run is /compact. It will run the compaction by default. Then there is /compact, and you can follow it with your own prompt. So /compact preserve key information, which is user related. So then it would focus on that information in the history and try to preserve that.
Nice. Sumant, hope that answers.
Yes. And
Perfect.
one follow-up question is, in the Claude documents, it says Sonnet doesn't support compaction and Opus supports. Does it mean we cannot summarize? This is a custom summarization, right?
Yeah,
We
this
can use
custom.
any LLM
Hmm.
in this case.
Yes. So given this is our flow, we can summarize and compact however we like. Right? Sure. Awesome. Dipesh, you have a question?
Yeah. So when we are talking about the eviction, right? Context eviction. So do we evict the prompts which were given by user also, or it's only the results coming out of the like either the tools, either tool calls or some other network calls, right? So like, can we evict both things, or can we like only the results, not the
No,
context?
imagine this. If you're evicting, like imagine this, you just evicted messages of 0. That was a system prompt. Right? You just evicted a system prompt. Ideally, you should not. But a naive eviction strategy, which is a sliding window based, you evict your system prompt. Now you can make it smarter and say, hey, I won't evict my first 3 prompt or first 3 messages because it contains my system prompt and what user wants to do. So that is your use case specific. Right? And then you say,
Right.
okay, after this, I'll keep shortening stuff. Like I will keep evicting stuff that I want. So which is where you typically have a system prompt placed explicitly. Your conversation messages is part of a different array. So when you are evicting, only your conversation messages get affected. But there it could also be like you might accidentally, like because of your eviction strategy, you might evict your actual task that user started with. But now imagine how difficult it gets. Imagine if you have a general purpose agent, how difficult it would get. Like, what do I evict? What do I not? Now, if your task is very specific and you know exactly what you want to do and what you want to get, that's much easier. But if you
Right.
don't know what's important, that's where summarization. That's why you see almost everybody or almost all frontier labs start with summarization as the best way to do it because you don't know what needs to be evicted. And imagine you evicting something which is super important just because you use a naive sliding window based approach. So answer is it depends on how you
Understood.
do it. So, but a good practice is system prompt separately, messages stored separately in an array, and when you're passing for your next prompt, you concatenate this, and then you pass it.
Got it. Another question on this summarization, right, which Sumant was asking.
Hmm.
So like he mentioned, Opus can do, but Sonnet cannot do summarization, right?
I'm
And
unsure on that. I'm slightly unsure
yeah,
on that.
we are unsure, but like just assume it's true. And
Let's assume it's false.
okay,
Because if you look at it, summarization is nothing but your historical messages, and you
exactly.
just have to
That's what I was.
summarize.
Yeah,
So
that's
that's
what.
why I would by default assume it to be false. But
Okay,
again,
got it.
because how difficult it would be
It
to
should not.
summarize the stuff.
It should not, because we are using Sonnet in our prod LLM agent.
Yes.
It's an
Yes.
investigation agent. So I was just
Huh.
wondering how our
Hmm.
system able to compact it.
Bro, you have evidence. You have anecdotal evidence. So you
Yeah.
should have assumed it to be false.
Yeah. Okay. Okay. Cool. Thank you.
Chalo. Thanks. Aryan, good.
Can we again go through the retrieval part? I'm very fascinated, why the context consumption is so less in that part. Like, how is it
Retrieval
even
part as
able to?
in?
So
Hmm.
there are three parts to it, right?
Yeah.
The
Eviction,
eviction part,
summarize, and external DB. Hmm.
yeah. So in that part, like, what is really happening?
So
Like
eviction, if
how?
you look at this is my cumulative context that I'm passing
Yeah,
in
yeah,
every call, right? What
yeah,
was our eviction strategy? The once I hit 90% budget, it goes away.
yeah.
So as soon as I hit here, if you observe, it never hit 90%. It never
Correct.
hit. So there is no eviction that ever got triggered. That's why you see retained. Yeah, nice.
Correct.
That's why non-deterministic behavior is so good. I could see different outputs.
Yeah,
Hot
before
got
it
it
was
नहीं है,
lost.
right? For summarization, it was lost because we were expecting in the exact command, right? Although we said it in the prompt that preserve commands, it could not due to whatever reason, right? And that's why you see the moment it hit this, which was we asked it to summarize every fifth step. We got this and then it summarized. So then the summary was literally shrunk from 1000 to 220. Now it's also fault of our summarization prompt where what we asked it to be dense something here.
Right.
Look here, into a dense, and like every token must carry information. Now this is enforcing it to be very succinct, extremely short, extremely abbreviated,
Yeah,
right?
actually,
So it's
my
forcing
question
it.
is on the
Good.
external DB part.
Okay,
So,
external
like,
DB. Let's go. Let's go.
yeah,
Let's go. So there literally every single line is getting added to external DB. So every time
okay,
the call happens, it fetches the relevant semantic information and then running it. I'm not even sending anything. If you observe, the usage is not growing
yeah,
much,
yeah.
right?
That's the most fascinating part.
Because I'm pushing everything to external DB. Here, I will show you.
And is it making a
Steps.
search call
Here,
at every
I'll
step?
show. Here, receive context, query text. If I greater than one, I query, I get the retrieve documents, and then I'm adding it. And then it goes. And then I
Hmm,
immediately add the document to the this. So depending on how many relevant document it could find, depending on the step, it's fetching it from the database
got it.
every time. And every subsequent conversation or message, once it's outputted, it goes into my DB. So
Got
I
it.
literally, it's a naive implementation where I'm literally fetching. This is kind of we discussed yesterday or last week. I forgot when. That what if we have this? I think it was yesterday when we were building this coding agent. What if we retrieve everything in the RAL flu? What if we
Yeah.
retrieve everything and then we run it? Right.
Hmm.
This is an example of that, where every time we are literally making a call, except for the first one because there is nothing to be made. Right. Every time we are making a
Hmm.
call, getting the result and then passing it as my context and getting the result, and then adding it back the context. Right?
Yeah,
This was
got
that
it.
example.
Yeah. No, this is pretty interesting. Thank you.
Sure. Thanks. Ankit, Kevin, I'll take your question in some time. Right? Okay. Awesome. Next up, again, it's not very heavy session, so don't worry, we'll have time at the end. Okay. So next, oh, it's already 1 hour. Oh, shit. Sorry, it's a heavy session. My bad. 1 hour. Okay. I didn't even realize. Okay. Next up is memory. Haha, round figure. Seal function I applied. Math.seal. Okay. Memory compression and summarization strategies. So now we saw summarization, how it happens, right? But that was a prompt that we provided. Now, different kinds of prompt. This is very similar to the prompt that I just gave on how it needs to summarize. Like you are summarizing an agent conversation for memory compression, preserve all decisions, numerical values, etc. You saw how similar the prompt looks. I just specified in addition to this a specific output format. Given my use case, I would want to do this. So now here you could play around with what is the best way to represent this information for your use case for agent to consume. It could be decisions. Imagine you don't need to have any decisions to be captured, but let's say metrics are important for you or what some numbers are important for you. You try to get that, right? More interestingly, your hierarchical memory consolidation. Now this is where your graph databases typically kick in. Where as and when the conversation is happening, and let's say I'm extracting decisions, open items. Now imagine you're doing, let's say, you're building an agent for an agentic SDLC. In that case, open item should be going into your Jira and like individual tickets needs to be created. So that is where, and again, that at the end of the conversation you want to do it. You don't want to make tool call on every ticket. It would be wrong, right? Let's say you want to create tickets after your entire thing is reviewed by a human. Okay, this is all good. Now I create. So in that case, this sort of structured information helps. This is also very true for your Google Notes type system. I'm just making notes so that I good example. So let's say note-taking apps that you have, it comes in handy for that, or your Jira tickets. But that you would want to do at the end of it after human in the loop is done. So which means when you're summarizing, you would want to summarize all the key decisions were made, all the open items separately, so that when you're showing the final Google Meet summary that Gemini sends you, has this in a very structured format. Like, hey, these are the next steps, what were decided, this is a summary, who said what, key decisions made. Now here, because my use case wants me to do this in a structured format, I'll ask it to do this. Right? So again, the answer is always it depends, but how it depends is what I try to bring in. Now the third one is the more interesting one. Now, the more human the use case, there is, if you are trying to make your agent mimic your human behavior, then you have to have a weighted retention. We as humans don't retain all memory equally. Not every memory is equally important, otherwise we would go nuts. What is important and what is not is typically what is more recent is what is more important for us. Everybody's talking AI because that's a recent gig. Right? Everybody's talking, hey, Fable did this, Fable did this. 1 week later, nobody will remember. So what was an information, important information, is exponentially decayed and eventually forgotten. So here you could add a weighted retention. For example, depending on the time when that information was registered and the time it spent, it follows an exponential decay, e raised to minus x or any variation of that you apply, and it decays as per that. Right? And once it reaches, it would never go zero, but once it goes below, let's say 0.001, it is forgotten. So this way, you're kind of mimicking human behavior, where something was important. I like pizza. 3 years later, what was the dish that I used to like? Oh shit, I forgot. It was round and had this, and then you try to recall. So you remember something, but you don't remember that exact information. So you're trying to do this. Now, where this comes in handy, where you're kind of building system that closely works with human and is human-like. Think of personal assistant. So what was it? Because if a personal assistant captures everything that you want, it should not keep every information as is. Because your preferences change, your memory evolves. You used to like X, let's say you used to like Java, but you worked on Go, now you like Go more. Right? So eventually you forget Java. Same stuff goes over here. So now imagine you had chat which says, I like Java. 3 months later you say, I like Go. 1 year later you ask your agent, what is my favorite language? It should say Go and not Java because Java has an exponential decay and you forgot about it. Right? So now this is also a way for you to reduce your memory. Again, if you look at it, you're kind of mimicking how we behave as humans. Right? But in this case, it's not always true that everything will be eventually forgotten. There are certain instances, certain memories that are there with you forever. Let's say you getting married. I hope you don't forget that and have an exponential decay on that, right? Or you have a baby. Please don't forget your baby, right? So whatever the critical event is, now this is what you would write in your LLM prompt to figure out, hey, this is critical, this is not. Like how your brain processes it to be important. Similarly, your LLM will process it to be important. One thesis I have not verified it, but how, I don't know if somebody has written a paper on it, but my thesis is there will be a need for a page rank like algorithm in memory. For example, if I keep referencing a memory, its weight should increase, right? And the things that are linked to that are more important versus others, or some variation of this, like what Google did with web searches with PageRank algorithm. Something can be done with memory, because if I'm talking about, let's say, my baby on chat with someone, because that is related to memory, my memory is, or sorry, that is related to marriage, my marriage should bump up. So things that this is linked to gets higher attention as and when it works, like kind of page rankish stuff. I have not checked. I just got the thought. I was like, when I was preparing for this session, I got that, hey, this could go into this page rankish direction. But again, if you'd want to pick that up, right? To explore. So one of the easiest way to do is something very simple, is like access multiple times, kind of like your LFU or like your anti-LFU stuff. If something is accessed multiple times, it's of more importance, and its least access time below a certain threshold in a time window, you remove it. Or if someone is explicitly, please remember this, you agent, this is very important, then you explicitly remember it forever. Right? Okay. Next up is, when do we write memories? We kind of saw after every 5 steps, you write memory to an external storage, or you try to persist it somewhere, or try to compact, or try to summarize, whatever. But when we look at write strategies, let's look at few of them. Like, not just strategies, but when do you choose to write a memory? When do you register a memory? First is, we decide what to persist. Not every agent decision, not every single conversation that you have is important, because the cost of noisy memory is very high. Imagine, we saw how we can just do semantic lookup to find stuff. Imagine you have lots of random conversation with that same word repeated again and again. It's semantically similar. It just bloats up your context and reduces your precision, because what you got, most of that was junk. Only one of the few point was important. So if you're just bluntly saving every single chat in your external storage or your memory, problem, your SNR ratio, which is signal to noise ratio, degrades. Your retrieval becomes irrelevant and very likely contradictory, because you just said some stuff in a contradiction fashion and it somehow was ranked higher, your output goes berserk. So good rule of thumb, again, not always a golden rule, a good rule of thumb is, you try to, or you should persist decisions that would change the behavior of the agent or future agent execution. Imagine case of a personal assistant, it could be user preference. Hey, now I like this more. This shows that I used to like that more, but now I like this more. So this is a signal for me to replace the edge that I just created. Arpit likes pizza, and now let's say next chat I say, but now I like burger more. This is an indication that I need to replace. Now imagine, by the way, we'll take a look at example of this next, which is evolving memory of user preferences, where what we do is we try to not always insert or append. Sometimes we have to upsert. That depends on what we are trying to do, what we gathered as an information out of it. That is the older state of this graph and edge, or this node and edge relationship, irrelevant. Should I replace or should I append? Let's say I say I like pizza, and then you say I like burger. This is a case of append. But if I say I like pizza, or let's say you say I used to like pizza, but now I like burger, this is a case of replace. Again, imagine these two sentences happened in 2 different chats for the same user in the span of 1 week or 2 weeks. This is where it comes in. Okay, so what to persist, how to persist, again, it depends on your use case. You need to understand what you're building, what information is critical, you extract that information and persist it. But remember, don't just blindly persist everything. Okay, now, few things to keep in mind around write canonical keys, descriptive, let's say user underscore user ID underscore preference underscore food should be your key if you're doing it in a key value store. Right? Be very verbose, because your agents understand, you just don't like pref, because it's easier for your agent to output preference versus pref, because it might get confused with something else, right? Then you tag your memory that just got created that you're writing with task ID, agent ID, or whatever. You need that observability system that if something goes corrupt, why did it go corrupt? If something got replaced, why did it got replaced? Which is the latest state that is getting reflected in your memory for the task for that agent, right? Just remember this thing in mind when you're building the system. Just don't blindly take things on its face value. We'll take a concrete example of this. The concrete example of this is evolving memory. This is what most memory startups that you see in the world are doing. They're just blindly making call to LLM to figure something out and say, hey, tell me what's important. So I'll first show you the demo and then we take it from there. Here I have to type something. Okay. So chat. So this is literally me chatting with the agent, and now you will see evolving memories over here. So I copy paste this. I am Arpit. I am engineer for Bangalore. So it went. It could not find anything. It should have found. Arey Papa, fine now. I am an engineer in Bangalore. Nonsense. Let me run it again. Let me run it again. अब तो find कर ले. It could not. A bug है क्या? No, I don't. ए भाई, oh Gemini. हाँ, shit. बच गया. This is 2.0 नहीं भाई 2.5. Sorry. 2.0 is now deprecated now. That's unavailable. That's why it failed. FI, this happens. Oh, by the way, remember this. Your models can get deprecated. So have those evals in place that when you get a notification from Google or whichever model you're using, you change your code. Otherwise, this happens. You get mini heart attacks in middle of a session. Huh. Good that this was in production. Okay. I do this. I copy paste this. It goes, calculates memory actions. So what I'm doing is I'm instructing LLM to generate actions for me. It generated action. Key extractions: Arpit, engineer, Bangalore. Subject is Arpit, works as engineer. Arpit lives in Bangalore. Right? Now, what I ask it to do, I ask it to output operations. Like upsert. Because if I tomorrow say I live in Gurgaon, this is a case for update, not append. Right? So keep this thing in mind. So again, I'll show you the prompt how I'm generating it because that is important one. Now I'm writing, actually I just moved to Bangalore. From here it would extract and say upsert Arpit lives in Bangalore. So this stayed as is. Arpit works as engineer because this was earlier as well. I'm just color coding it so it becomes easy visually. And Arpit lives in Bangalore. It literally did an upsert. Right? Next up, I say I'm now a principal engineer too, working at Razorpay. It says it extracts stuff and says Arpit works as. Now here it was engineer. Now it evolved and said Arpit works as principal engineer too at Razorpay. It did not do append. It realized that this is an upsert case because it is works as. Again, here we are relying on intelligence of LLM to output the operation. LLM can go wrong. These are evals come in, which we'll discuss next week Saturday. By the way, on how to write evals. And then lives in Bangalore stays as is. The yellow one stays as is. Right? Okay. Next up is I primarily code in Python for AI. Now here, look at this. This is kind of graph that it's doing. Now it says add. If you observe, it did add for Arpit codes in Python because I could write Arpit codes in Java also. In this case, it did not do an upsert. It's not asking me to replace. It's adding it because it intelligently identified this is an addition use case because it's codes in, because this user can code in multiple languages, right? So this is a new line that got added, right? Next, I'm starting to use Rust for performance critical goals or performance critical parts. Ideally, it should append. Yes. Yeah, bro, because of non-deterministic, you get so joy that it worked fine. But this is what also happens in production. Here you see codes in Python, codes in Rust. Right? Because it identified it's an add, not a upsert. Okay, next up, I'm meeting Sam at Sardo Sofia today. Okay, so meeting with Sam, meeting at Sardo Sofia, meeting date today. Right? It extracted and added. The meeting with Sam is moved to next day. Now imagine next day I write this. Meeting with Sam is moved to next day Tuesday. Now meeting date change. This remains as is. Meeting date changed to next Tuesday. Right? Here it identified it to be upsert. And that's the important part. Right? Because meeting date is something that could change. Now I change Sam can't make it. I'm meeting Sarah instead. Now meeting with would update. Look at the operations. Upsert Arpit meeting with Sarah. Everything else remain as is. Now what I just demonstrated is most memory AI startups. This is what they are doing. For every conversation, of course, they are not doing it for every line of command or every conversation. Some of the heavily funded ones were actually doing that, and then people call them out, and then blah 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 blah, blah, blah happened. But you see how easy it gets to build your. It's a toy layer, of course, but here there is a lot of opportunity for you to save cost by using a weaker model or a cheaper model to extract that information and do it in batches for a set of command rather than for every single conversation. Now you decide how you want to do it. You can club it with your standard named entity recognition, etc., to make your life easier and you being more CPU bound versus more LLM bound, right? This is an example of working memory. Let's go through prompt. The prompt is very easy. Okay, here you are a memory extraction engine. Your task is to analyze user message and derive specific memory actions like add, upsert, delete. This is what I ask it to do. That because I wanted operations to be outputted so that I can make changes to my graph. The graph that I'm doing is all in memory, right? There's no graph database that I use. I just built a graph in memory that it's storing. It's actually a list, not even a graph. It just literally does a linear scan, finds the entry, and then it replaces or adds. That's what it does, right? Critical rules. Do not try to fix or reconcile with current memory. Simply extract actions based on new user messages. Action type add, when to use it. Upsert, when to use it. So now here, lives in, works as, current state, likes, has skills. So you are being very prescriptive to agent on what constitutes add, what constitutes upsert. You'll be like, but Arvind, I am building general purpose agent. Don't try to build general purpose agent. You will most likely be building agent for a specific use case. For that use case, use relevant examples and let it act as a prescription for your agent to see what is important and like when it should call add and when it should call upsert. Then you have delete. Then use crisp uppercase relations. Now what I ask it to do is when I first built this application, it did not have this thing. So sometimes it tried live space in, sometimes it did workspace as, sometimes it extracted as is word from my text and put it there. So then this instruction was important because now I'm giving it a uniform structure on how a relation would look like so that duplicate detection becomes easy for me. Then respond only with valid JSON object. This is how I want. And then when I get it, I update my action. Now this is where I get memory actions and then I act on it. Memory actions and apply actions. If you look at apply actions, I'm literally look at these changes. Memory. Look at this memory. It is literally a list. It's not even a graph. It's literally a list because it's a toy example. Ideally, what you could do is you could write it into a graph database. When you extract memory, you could write it to a graph database and then use a Cypher query or whatever to retrieve it if you want to. But it was a toy example. I just use list to do it. Dead simple. Right? I just wanted to keep things simple for demo purposes. Right? But this is how you build your evolving memory for like toy example. But this is now you can make it as sophisticated as per your use case. Okay. Any questions till this stage? Good, Rohit?
First is that this is I know this is a toy example, but in normally we would not in our prompt we will not mention that written in JSON, right? We will instead use Pydantic.
Of course. You'll use Pydantic model, pass it as metadata information in your tool call or not tool call into your prompt where you define it. Like this is how my output schema should look like, and it would respect that. Yes. I just wrote it because
Okay,
it was
and
easy JSON for me to write.
right. I got it. It's a toy
Yeah.
example. And another thing is that when you change the person you are meeting with from Sam to Sarah, it still kept that meeting place as Sourdough Sophia.
Yes.
But
Because that's
this
what I
is
asked.
somehow
Because
wrong, right?
no, I just asked. Sam can't make it. I'm meeting Sarah instead. I never said where I'm meeting.
But okay,
I'm meeting Sarah instead. Must be at the same place, right?
could be at the same, not must be, no?
Could be at the same place, right? So now now imagine if the meeting gets scheduled, Google Calendar invite can flood in and can replace this event. Let's say, no,
But otherwise, can we have like more relations, like with whom you are meeting? Like
Yes.
right now you have subject, relation, and object. Can we have more columns?
No. Typically, you do a 3-tuple format, subject, object, verb. Your graph database is also that. Node connected with the relation.
Okay.
Right? It's not a SQL database. Correct? What you are doing is a graph relationship. Subject, object, verb kind of stuff. Right?
Okay.
Right? Now here,
Yeah.
I am also meeting, let's say, Pratik at McDonald's next Wednesday. I don't know. It should do good things here. It should add rather than upsert. It upserted. It upserted. It removed Sarah altogether. So that needs to be added. When I say also, it needs to do this. Now you see, it's very susceptible, very error prone. Right? Now imagine how complex your prompt will become. Right? No, do not remove meeting with Sarah. Let's see what it does. I don't know. We did not do anything. Hey, it did not do anything. User said something and it did not even find anything. Wait, let's do it.
Does it also
It's
depend
okay. It also
on
tells that
the
these things are not silver bullet. It's not for every
I
problem.
know. I know. I'm just trying. It's a toy, right? It's a good toy to play
Right.
with. Why not? Again, this shows, and this is also shows importance of evals. Right? But ideally, it should not have replaced. But I think it would have been in the prompt meeting at or something. No, I don't think it's prompt. But add absurd this for the fact that we should have only one value at a time. Lives in works as current state. If the user mentions new value for this, system will replace the old one. I never mentioned it, but it's not as you said, it's not a silver, right? It's all error prone. Right?
Right.
Chalo.
Thank you. Thank you.
Good, Pratik.
Is
What?
there a
क्या change करूँ? बता.
नहीं change नहीं मुझे like I wanted to understand like so based on this toy I could have any number of relations created, right? So, but ideally in production, you would want to have a limited corpus of relations that you
Yes.
want to say because otherwise every statement can lead to a relation that is stored in the graph database.
Yes. So best way to implement in Pydantic enum data type, define all the relations that you have so that it respects that
Correct.
schema.
And then LLM should also get that schema so that it knows about that. It is a fixed thing.
Yes.
Outside that, I think one other aspect I was thinking of is if you also wanted to link to the actual memories that you had it somewhere, but the output didn't show it. You are linking it to the actual memories also, right?
Yeah. Here. It had it here, self.memory. Here. यहाँ पे, and then I get changes. Oh, yeah. Here is a self.memory is what I have. And linking as in to the text,
So,
yeah?
yeah. So the actual text that
Here,
produced it. We
fact-tuple,
talked about
fact-tuple.
having the for debuggability on what is producing what memory produced the
Yeah. I had it. So that was an explanation, not in the code.
Oh, okay.
That is an explanation.
Yeah.
And again, this shows why it's important because now you need to know why that bug happened.
Exactly.
Again,
So,
audit trail.
so I was thinking if the last there were 3 columns, right? The last column should also contain like
From
it's
where
an
it came.
object. Yeah, it's an object, so
The
it can
chat
contain
ID, the chat
Exactly.
conversation ID from which it came.
exactly. Yeah.
Thanks, Pratik. Akash, good.
Yeah. So, 2 questions. So, can we use something like Spacey to do the NER and save some tokens?
What's the assumption if you're using Spacey to do NER? That it's a legit English text.
Right.
Right?
Right.
LLMs are
Yes.
smarter. But if you know that you are getting, imagine you are doing with news articles. You could rely on Spacey. But if you are talking to a human and human agent extraction, they will write in different languages in the same chatting conversation. Right? Then it becomes tricky. As I said, you could always fall back to, or you should always prefer classic ML, classic DL, classic NLP strategies to do things. If you know that input is well formatted, it's legit, it's what those tools expect it to do or expect it to have. But if you're dealing with a lot of uncertainties, imagine a customer support agent, then you typically would want to rely on LLM more.
Right. one more question.
Mhm.
So this very much looks like MemPalace. I think it's an open
Oh, yes.
source
Yes.
memory tool. Yeah. Okay. Cool.
Yes, yes. Very similar to that. But again, now you see where like most of them do this, but with higher efficiency, like with respect to token consumption, so they typically do 5 or 10 conversation messages and then extract one out of it, right? And then they have a filter or with respect to number of tokens so that they don't like they have strike the balance between because they have a system prompt and then they provide the input and this stays within a limited budget because they have their evals which says that this is the optimal number of tokens at which it would run fairly well, right? And then they decide as per that.
Right.
Yeah.
Cool.
Sure.
Thank you.
Awesome. Yeah. Abhishek, go ahead.
Yeah, Arpit, I know it is a toy example, but so the thing that we are doing here, so actually, isn't it too costly? Like,
Oh,
for
yes. Yes. And companies called out people who were doing more deep research on building memory layer. They did call out other startups that were doing LLM calls on every invocation, like every chat message, right? So
right,
now think of it. This gives you your playground to play with. And now you can go and, for example, as Akash was also mentioning, if I can assume that my input is like pure English text, well formatted like news article, I could just rely on my Spacey or whatever NER library, like say Stanford NER library or Spacey to extract name identity recognition. Because tuple extraction from text is a solved problem for good English text.
right,
It's already a solved problem, right? Pronoun disambiguation is already a solved problem. Right? It's just that LLMs are just like people are just using it because they can. The underlying expectation that why people are using it is because it made their code simpler, number one, more accurate, number two, and token cost was consistently reducing. Right? Once it hits the floor that it cannot go below this, and token efficiency becomes a thing, then you would start seeing a traditional MLDL algorithms coming into fashion again.
got it.
Sure. Thank you. Suryansh, good.
Yeah, I mean, I just wanted to see like how in this example you are doing an upsert. Is it like the first verb match
First
or
verb match. First verb match. Here,
that
observe.
could I think also explain
Yeah.
Why it would
Replaced.
replace so yeah, I mean in actual productionized cases there would be a different, I think, method to upsert or something.
Yeah. So that's why you would use a graph database to do it.
Yeah, okay.
Hmm.
And another thing is that this update is like whatever we are adding to this graph database is also a tool call in itself, right? Or
So here I'm not adding graph database, but you don't need a tool call because it's imagine in real practical solution, this would come as a stream of events through Kafka to your system. You are not doing it in an agentic loop. Fair?
so the the AI response is basically subject verb object that way.
No. So you would not do it in agentic loop. What you would do, because here I did it synchronously. Right? But in production system, imagine you're building a customer support agent, correct? Or let's say your personal assistant agent. Would you want to extract the subject object verb synchronously and update in your database? Not really. Because at the end, this conversation is also going into a database. You can have a CDC pipeline. Consumer consumes, extracts, and updates asynchronously. You don't need a synchronous update for that. Fair? So now you can use a separate model to do this. You don't need to do it in your in context window that you have.
Okay, that's why it won't be a tool call as such. But the output from LLM is in the format of subject verb object, right?
So that's what I did over here. But ideally, if you're using a hyperquery, you can ask it to output a hyperquery and just run it. Ideally, you should not do it. You should make it output an RDF tuple. That's a better way to do it. Like subject object verb is a better output format because LLM is more structured into outputting a subject object verb because it's easy to extract that information.
Right. Thank you. This was helpful.
Thank you. Okay, Sajal, Pratik and all, I'll take question in some time. I just don't know how long it would take for me to cover the multi-agent, but as I'm just being cautious. But again, we have lots of data. Okay, thank you. We'll move to the next part, and now we'll discuss multi-agent. Multi-agent, relatively very simple. The idea is that one agent could not do things. We are hoping multiple agent would do things. Okay, we kind of touched upon it yesterday, where which was kind of like your plan and execute thing, where we discussed that hey, there could be things that I could do in parallel, right? That is what the multi-agent use case is. That is one doing parallel, right? So multi-agent is you having multiple single agents running, right? Because if you're just doing everything in your one agent, you see how complex your agentic loop gets. Treat your multi-agent as your microservices architecture. That's a loose analogy that you can apply. Would you have a monolith? Would you have microservices? Each service doing its own thing really well. Each service can use its own database. Each service can use its own architecture. Architecture here is your agentic loop. Database is your model. Right? That is your that is your multi-agent flow. Right? Which is where it's interesting how that handoff happens that leads to a problem which we'll discuss in some time. Right? So now think of multi-agent is that you have a single agent. It has a large context. Treat monolith. You start drawing analogies to monolith and the tools good enough for most use case. But if your task can be split into multiple subtasks, if your multiple subtasks can execute in parallel, if by doing those things in parallel, and those are like pretty independent tasks, you can speed things up. You want specialized model to solve this one problem. For example, planning by Opus, execution by Sonnet. Right? Or let's say Gemini is great with English text. I would use Gemini, and let's say I might use some model for Hindi output or whatever multilingual output that you would want to do. That is how, or for example, if for a task I have longer context, I would use a particular model, and for other tasks I would use a different model. I would want to do that. That is how you decide you'd want to do multi-agent. On other case, you can also think of it as single piece of responsibility. Like, hey, this agent does this work, only this work, this agent does this work. For example, this agent just takes care of refund part. This agent gives me everything about shipping and takes care of shipping. This agent does planning. This agent writes code in Go. This agent writes code in Java. Right? You could do this. This does a code review in Go. This does a code review in Java. Imagine you have a monorepo where changes are both in Go and Java. You would invoke Go code review agent to do this and Java code review agent to review Java code. So it's all about splitting of responsibility. So very loose analogy for that is monolith versus microservices. Okay, let's look at first pattern. For this, we'll look at prototype as well. Orchestrator specialist pattern is what you would very likely be using to build multi-agent. It's not the only one, but very likely you'll be using orchestrator specialist. Idea is very simple. The idea is I would want to split my task. I have an orchestrator, which is orchestrator. This is your LLM task that you are given. Orchestrator splits kind of step and kind of plan and execute. It splits into multiple subtasks, hands it off to specific agents, waits for them to respond. All of this agent does its thing, responds to orchestrator. Orchestrator keeps adding it to its context window. Not every single message, but output from the first agent. Right? Imagine it wants to process refund or something, it wants to process refund. It hands it off to refund agent, which runs its own loop to verify this, that, and outputs yes, that refund was already given for this order, and this one final output, because there's an agentic loop that is running for this subtask. It gathers that information, just that one information, final information, and gives it over here. It's not a tool call. Tool call is external call to a system. This is literally an agentic loop that it ran multi-step reasoning on its end and generated the final output. This output goes to orchestrator. Orchestrator keeps track of everything that it has and decides what to do next, Orchestrator can then make a few tool calls to get subsequent information. Even a sub-agent can make few tool calls to get subsequent execution, like subsequent information. Right? Okay. Now, we'll take a look at practical example for this one. Practical example, 2 uses and then 1 prototype. 2 usages, imagine you're doing a customer ticket triage. So imagine your ticket can be anything. This is your main agent that received a ticket. That agent needs to see until this ticket is resolve. Right? That is a loop that you write that goes and figures out what needs to be done, reasoning token outputted, decides, hey, this is where I could want to, this is a task that I think is payment related, or rather this ticket is payment related. Let me hand it off to payment agent. Now, how does the handoff happen? Handoff is nothing but you decided I want to hand it off to this one. So you can create a sub-process, a Python sub-process, and make it run the other function which starts a sub-process and it executes that part. It could be a separate file, it could be a separate thread, whatever. If it go, call a separate Go routine, right? That just calls this as an agentic loop and gathers all the information, solves it, and it gives the output. Right? So here it's a sub-process or a Go routine. You could also do everything in a single flow. You might not want to do anything in parallel. Given that the ticket that you are receiving is, I want to hand it off to payment agent, you're literally just calling the payment agent's code and it's adding that stuff either in this context, ideally you should not do that, but or in this its own context, and it runs. It outputs output. If you're using a separate model, then you would have a separate Go routine or something, its own context window, etc. That's a better practice. It outputs and it runs over here. Similarly, if you look at incident triaging, where I might have an agent which is specialized in looking at metrics, this agent also just has access to metrics tools. Now, another benefit of using multi-agent is tool isolation, which is metric agent should have access to metric tools. It should not have access to log tools. My log agent, which is specializing in analyzing large amount of text to extract the critical information and narrow down the bug. So I can, when an incident happens, I can just fork it off and say, metric agent, go find relevant metrics for this one. It would run its own agentic loop, find relevant metrics, generate the final output, return it to the orchestrator. Python sub-process or Go routine, whatever, right? Then logs, go find it out, figure it out, generate the final output, send it. Source code, go find out the relevant pieces of information and give me. Now all of this goes into context, and this main loop orchestrator is reasoning. And in reasoning, it could make tool call, it could make hand it off to other sub-agent. Let's take an example of a deep research agent. How to write one. This is the final prototype for today. Again, we have a system to cover, but prototype wise only 3 prototypes for today. So here I take a deep research example where if I run, it asks some, just close it, OCD, sorry, Python main.py. And I would open another window where it runs here and copy, paste. Okay. Watch. Okay. So now here, should prefix this with the watch. Okay. So now here what I'm doing is I'm doing a deep research. Let's say research topic. Research topic is Tau Ceti. Sorry. Let's say why was Pluto? I made this shit up. Why was Pluto removed from planets in solar system? Sorry, Hail Mary effect. I watched it second time today. Okay, so now what it's doing? It's doing my lead planner agent. This is kind of my orchestrator. Then I have a specialist agent. One makes web search. Second goes and does concept specialization. Then I have a research critic agent. And then I have a lead synthesizer agent. Fancy name. Does nothing fancy, right? But now here it's split into subtasks. Here you saw it was just one. But now you see 3 Python processes running. Once that job is done, you would start seeing this chopping off. So now it goes, it figures out it needs to do this, and we'll take a look at the prompts as well. Right? I want to show when a process is complete, you would see this going away. Right? So it goes, your lead planner agent, first it created all the subtasks. Then it realized it needs to do concept, which agent it should assign to, and it assigns a task to that corresponding agent. So research critic and all of this is happening in parallel, right? Now all of the task is done. These 2 tasks are done. It goes, does a web search, etc., etc. The research critic agent is conducting cross-report gap analysis and audit, completed review. Now it does critical gap analysis, which is this one, critic agent, lead synthesizer. It does critic. It says as a research critic, review the parallel reports and find gaps in conflict. This is a prompt that was sent to that agent. It does this outputs, and then I have everything over here, and this is my preview of the report, right? Now look at this, everything is done. So it literally forked off Python sub-processes, do things independently, but now how does the handoff and all happen? Let's look at it. So here, research sub-agent task, research plan. So what I'm doing is this is like simple Pydantic models, what I have, generate plan. You are a chief research planner. I found this prompt somewhere and asked Gemini to modify it. Given a research topic, your job is to break it down into 2 to 3 distinct, highly focused subtasks that can be researched in parallel. For each subtask, determine whether it requires web search or self-knowledge. For theoretical concept, fundamental physics, make sure the subtasks are complementary and do not overlap. So that's why you see when it spits out, it outputted here this. Then is it self-knowledge sufficient? Or I need to do a web search for that. So I did web search for astronomical discoveries challenge Pluto status. It figured it out, and I need for this Pluto discovery in early and the resolution that happened, it's self-contained part. Right? Now you could hand it off to agents. Like how exactly? Let's do it. Run research task. Here I'm doing, you are a web search research specialist. Your job is to do this. So now my system instruction, if you look at this, changes. If my task is web search, I'm doing this. Otherwise, I'm doing this. Now, what I'm doing is this run research task. I'm saying what is a subtask, what is the task number, and this research task is here. Where did it go? Here, run research task. So I did plan.subtask. When it got a subtask, I'm calling the same function for each of the subtask. Here, I did task.append, and here I called async.io, which created multiple sub-processes, kind of, and it scattered and gathered, and then it passed it to run critic, run synthesis, generate final report. Here's the final report. From 9th planet to dwarf, from 9th planet to dwarf world. Oh, classic GPT. Classic LLM. The definitive account of Pluto's reclassification and the evolution of planetary sciences. Right? And then you get this final output, which is the final research. Right? Some things it came from, what do we say, web search. Some things came from self-knowledge. Now you can add more sub-agents. The whole idea is to do scatter gather. The magic sauce is this async.io.run. It calls this main function where it gets task and gather here. This is where it gathers all the tasks. It's wait for it to complete. Once it gets everything, then it proceeds further. So all the things that I wanted, I just added it over here in this one, and my job is done. So this is where, imagine this Go routine and this is your wg.wait, or your Java and you have something to wait until all the threads are done doing its thing. Kind of that. These are simple deep research agent that you can build. You can make it as sophisticated as you like. I just kept it short enough for us to look at a demo in the session itself. And it's a different report that I generated. Can I see different report? Earlier report was git diff research report. Research report. Yeah, earlier was unveiling the inner workings of LLM. I asked it to do how LLMs work on that topic. But now I ask it to do Pluto. Just to show it just works. Right? Okay. Any questions on this? Like how that agents are splitting, scatter gather. You see why threads, processes, OS important. That's why. Okay. Aniket, good.
Yeah, this is basically agents inside the same code base, right? But if let's assume we are having multiple code bases and we are talking about A2A in that case, right? So multi-agent. So are we going to discuss that as well?
No, so A2A protocol I'm not covering, but one of the easier way to implement this is put it into a shared memory, which is, let's say, your database, in which one of the worker is polling the database. If something needs to be done, then it forks up a process.
Understood.
So A2A handoff is very problematic as of today. It's still not mature enough. Most people would rely on having a shared state because everybody wants that high observability and state management and like checkpoint and resume, right? So simpler way to do this is to just upload it or like update it in the database when the subtasks are created, and then someone polls it and then forks off different thing within the same machine, or some other process is listening. So depending on who the owner is, that corresponding machine polls and forks it off, right? So
okay, so basically via
task
state
scheduler
management
system, via state.
Okay.
Sure. Thank you. Which is where you see temporal and airflow getting traction with LLMs in place, right? Because now every machine can independently pick that up and run it.
Yep.
Sure. Thank you. Sajjan, go ahead.
So, can you go to the part where like you're forking off sub agents? I just wanted to understand like how does the orchestrator like tell like what exact thing are you parsing for in that response from the orchestrator to fork off
Okay,
sub-agents?
here my orchestrator plan has subtask. If you look at this, I ask it to, this research plan was provided as my Pydantic schema so that I get subtask. That's doing the heavy lifting. So the subtask splitting is literally a structured output is what I got here. And that is part of my research subtask, which has a title, a description, and an agent type, which is a web search or what. So then it goes and picks it up and executes as different async IO loops.
Got it. And I'm guessing like the sub-agent in this case does not have access to like the conversation that the orchestrator has had.
Yes. So that's why orchestrator should not peek. It's like literally, if you have given your thing to your SD1, you should not look at it. You should just care for the output that you are getting. It doesn't peek into it. Once it's done, it outputs. Like, and again, that entire state management, if it's different machine, via shared storage you can do. If it's within the same machine, you can just use a shared memory. Like in this case, I just use the shared memory to get the output.
Got it. Thank you.
Sumant, go ahead.
My main question is when to use agents and when we are okay with skills itself. Agents is when RBAC is needed between agents. We don't need tools to be shared across different work. So agent is better for kind of RBAC between agents. Otherwise, skills in the same agent is okay.
But now, how are you executing skills? That's why you need agent SDKs. If you're doing it programmatically, right? So here the loop is implicitly done by your agent SDK, which is your Cloud Agent SDK or Anti-Gravity SDK. But then they are running the loop on your behalf. You're just passing your skill file to it.
Understood.
Okay.
Sure.
Thank you. Saurabh, go ahead.
Yeah, just one question, Arpit. So here, in case of multi-agents, the common layer you're saying is the state management you're doing on the same machine because you know that all these agents are going to run on the same system.
Yes. It's a toy example, that's why we do it. But as we discussed, right, in a distributed setup, you use a central database as a state manager.
So then how means every agent needs to know, right? Like where to look for state or like
No. This won't be part of your agentic loop. These are regular Python loop that you will write to poll the database to see if is there any task for me, any task for me, any task for me, any task for me. Or a queue.
But then it won't be orchestrator of this pattern, I would say. Let's say if you have a pattern where you're first doing the planning and there's an orchestrator that needs to keep executing agents one by one.
So then even your orchestrator loop, your agentic loop is still Python code.
Yeah.
Where it can make a tool call. Imagine there is a tool call which says wait for all subtask agent to complete. That tool call is looping and checking the database until are all subtasks completed or not. Correct. It's not your it's still your agent doing, but it's not your agent English language thing that you wrote that hey, keep polling until all the subtasks are done. Correct. So what you can do is you provide it this step that plan all the subtasks to be executed, hand it off, make a tool call and wait for all subtasks to be executed. So agent will automatically make tool call. You will have a call which calls that function which polls the database, and that function you are invoking as part of an agent telling you to make a tool call. Rather, you could just avoid that LLM taking that call and you can add your own thing. Once the imagine this, I'll show you like how. So imagine your subtasks are created. Subtask, gather. Okay. Imagine here, your subtasks are created. This is where your job is done. Your first research task, plan.subtask, plan it came over here, plan came over here, generate plan, right? Now generate plan is your orchestrator ran a loop, created a subtask, right? If it wants to run a loop, it can run a loop, right? Otherwise, it could be just one LLM call and be done with it, correct? Now, here you can write, because you are executing, you can write literally poll to write, like not literally, but literally for db.call, you pass the queries, select star from whatever database to do whatever state where agent ID is whatever, right? And then you have a loop until all subtasks are finished. You are literally making this call. to do it. Sleep 1.0, for example. Right. So
Okay.
then after you spun up all the task, then you're waiting for it to come. So here that async io.gather that did that stuff for you, you could add a for loop. This is like a classic short polling example.
This is basically build your
Got it.
distributed job scheduler.
Yeah.
That's it. That's
Right.
it. Now you could replace this with temporal.
Yeah.
So temporal, replace this with Airflow DAG. Correct?
Yeah.
There, that entire this workflow management, because here we knew we are creating a task, like we are creating a plan and a bunch of subtasks, and we have to wait for all of them to finish. But your workflow, there's a kind of a workflow. Your workflow can become very complex. It needs to be executed in a distributed fashion. Who can execute what? You have different worker pools. Each worker pool, imagine it's an agent worker pool.
Yeah.
Correct? Now you can make it as sophisticated as you like. That's where your temporals and DAGs and like your Airflow DAGs are doing wonders, right?
And then each of those would also need to know, right? Each independent. So this
Yes,
is the
that's the
main
code you
orchestration.
write. Yes,
Yeah,
yes, yes.
because each of those are also Python code in itself. So those
Correct.
agent also needs to know where it should persist, and there can be
Correct.
interdependencies between those sub agents as well, right? So at
Yes.
times.
That is where your DAG comes in. That is the final system that we'll discuss in this course, where we build a natural language workflow engine. Right? So that is literally your workflow that you're designing, which can go scatter, gather, wait, and then fork up multiple things and do. So this is like your n8n workflow sort of stuff.
Got it.
Right?
And I did not get what you said about A2A, like, because
It's a protocol. If you're not aware
yeah, I know
of
that. I know follow it Google prepared, but like in this case, where would it be useful?
it won't. Here, one agent wants to hand off task to another agent within the same machine, you do it. I'm not sure if they've added it in a distributed fashion, but I found it to be very buggy, at least till this stage. So that's why I'm still rely on my classic old school database scatter gather format for me to operate with. Again, I'm just waiting for that A2A handoff to become mature enough for like everybody to use. That's why you just see Google announcing 1 week, everybody talking about it, then it's like pretty quiet. Everybody relied because now temporal and Airflow are becoming the temporal Airflow and n8n are becoming the preferred choice for to do this workflow because it's much easier and much more deterministic and much more reliable. This A2A is still iffy at this stage.
Got it, but it would be more distributed, right? Kind of, or more generalized when you want to create. Then you
That's
might
the
have to go
problem. You
for
don't
that.
need to overgeneralize it. Your temporal input works just fine.
So it's like when you would always try to create a like deterministic kind of workflow. Means you know
Yeah.
that what you're doing for a particular task and you code that in temporal rather than making it very generic and figuring things out on the fly.
Yes. Perfect. That is what you like. If you know that you have to wait for all subtasks to complete, why to let it be a tool call? Why can't you just be done with it and like write a while loop like this, right? That's the same thing. Like let your agent decide that it needs to wait, or you know it needs to wait to waste tokens of your agent. Pradeep, add please.
Yeah, when you said that it needs to be deterministic, if you think about it, you wouldn't let your production workflows be like, oh, I will call one agent which can spin 1,000 agents or 100 agents or 10 agents, depending on the task. There is no determinism there. You cannot possibly have an SLO against that endpoint anymore because you don't
add
know.
karna wala tha. I was going to add this. The robustness and the reliability of the system is still in your hands. Like you cannot let your agent say, "Yeah, what our agent does is right." Right now, everybody unfortunately is just handing off to Claude Agent SDK and expecting it to do wonders. But I think the reliability of your production system is in your hands. You are accountable for it. Are you sure what it is doing? That's why use LLM for intelligence, not orchestration. If your task is fixed, you exactly know how it needs to execute. By the way, we are struggling with the same thing with Agent Studio at Razorpay. 2 months ago, we evaluated that can we have from a natural language create a deterministic workflow, generate code for each one so that our merchants, when they run, they should not expect one time it's working fine, second time it did not. That's a bad user experience, right? So they should be very sure what it's going, how that behavior is, right? So you would tend to go towards more deterministic path, and you would see in coming months people moving towards more deterministic path and using LLM for not like entire orchestration, no matter how much of loop engineering comes in. Your production systems are way ahead, are too far away from your production systems, where
Yep.
I said production twice, whatever.
Yeah.
So your toy systems, I wanted to say something. So your toy systems that you're doing, your loop engineering and full agent orchestration versus what your user expects. Because your user is not saying, oh wow, this company is using AI. I'm okay with some non-determinism.
Definitely.
They
Yeah.
say, I am paying money, I want output. Right? So
Yeah.
like be very mindful of that fact, is what I want to highlight.
Okay.
So,
Thank you.
perfect.
Yeah.
Thank you.
Yeah, and what you
go
can
ahead.
build is and what you can build is like an orchestrator platform where it's a generic agents have like specific roles defined at a higher level, but then you have this workflow where you can kind of connect these agents in whatever fashion you want for your specific use cases, and then you can have kind of specific prompts, like user prompts that you can define that way. Then you can build different multi-agent systems from a platform agent system, essentially.
Yeah. So what Kevin is saying is it's a deterministic flow. So you have, let's assume you have a flow where you are doing and calling an agent to identify the language of the user. Then you're moving ahead based on that choice of language. You can then call another agent which understands English, another agent which understands something else. But this flow is always deterministic. There will always be one path to be taken for a particular thing that can happen. It will not be that agent spawns 1,000 other agents.
Correct.
Awesome. Okay, we'll take few more. Rohit, good.
Yeah, we don't use any AI in our backend system, so most of the use cases are like just like looking at logs or such things, and we just use skills. And should we think about using code to do such workflows, or are skills enough? If you have like a simple workflow, like not like a
If
deep
it's
research,
simple, and your skill is deterministic and you're okay willing to spend few extra tokens, then skill is good enough. If you are trying to manipulate or edit it and it's easy to describe it in a very natural language, and you know that Claude, for example, Claude as a specific example, is good enough for it to figure out, just your skill, because it makes your GTM faster. Correct?
Yeah.
But if your customer, if your user is expecting that full determinism, and or you are chasing efficiency. So right now, all workflows of Agent Studio are skills. But what we are not doing is we are not optimizing on cost at the moment. But the moment cost factor kicks in and when we roll it out to production at scale, right now it's still in production, but for very small subset of merchants. But the moment it gets rolled out in production for a large scale of merchants, things would change. There, we would convert this skill into deterministic workflow and then run and only make LLM calls where it's essential. Right now, our skills is doing orchestration for us, which says if I'm building an agent which is doing, let's say, subscription recovery, or let's say, let me take an example, abandoned cart, which means if someone paid, added to the cart, went to Razorpay, added to cart, went to Razorpay, did not complete the payment, we give that user a call, negotiate it. That entire workflow is written in a skill that runs periodically, that figures out what needs to be called, where it needs to be called, who needs to be called, how it needs to be called, how it needs to be negotiated, etc. Everything is a skill. Or that entire, and because right now we are iterating, we are getting more customer requirements. Our skills are becoming mature. Once we know that this is what we want, and token efficiency and cost efficiency needs to kick in, because once we roll it out to millions of merchants that we have, that cost will balloon. We don't want that. Then it gets converted to deterministic. So start simple and evolve, but make sure like you know how to convert into a deterministic workflow, and just use LLM. Like again, use LLM for intelligence. Not denying that. There you need it, but orchestration can be waved off to your temporals of the world. Temporals, DBoss, Agno, whichever one you prefer to use. Okay. Sure. Thank you. Suryansh, go ahead. Oh, Baba, there's a topic bhul gaya main baat karna hai. Sorry. Go ahead, Suryansh.
Then quickly, then like I just had a question based on like the discussion you guys were having with Saurabh. So like I was looking into, like, we definitely have these different agents SDK, like OpenAI agents SDK and all of that, but in production, like whoever's building, like your Pith and Pratik, basically, are you more relying on the response API and owning the loop tool dispatch and handling state yourself, or are you guys using Agents SDK as of now in production?
I am full agent SDK right now. So again, because it's all GTM, it's not operating at scale at the moment for us. But once we hit that limit, right? Once we scale, answer still remains the same. Once we scale, things will change, right?
Okay.
So we are still figuring. It's like MVP phase, right? You're using agent SDK where your iteration on skills is easier. You just English,
Right.
English, right? You rely on Claude's intelligence to do orchestration for you. But the moment you go for scale, this will become very costly. Because imagine if you know you have to wait for 5 minutes, why you want an LLM call to decide that I need to make a tool call that makes me wait for 5 minutes? I can decide. I know my workflow is going to wait for 5 minutes at that point. Correct?
Got it.
Sure.
But
Awesome.
these Agents
Good.
SDKs are also like can you build temporal workflows with these Agents SDK?
They're
and-
smart enough to do it, by the way. You can have like temporal, like way to generate temporal code out of it, because it is just Python code at the end of the day.
Oh, okay.
You can just add a decorator, it would generate a temporal code for you. You have a human in the loop that validates it once you, and again, that's the productionized part. That's the last design decision I took last week around how do we do this natural language workflow split and making it into deterministic flow. That's literally my last Friday discussion with the team. I did a prototype with Agno. Agno is a framework that that creates an abstraction to build agentic workflows. So AGNO, in case anybody wants to take a look at it. Sure. Aniket, you've been waiting for last time. I'll pull you in and then we'll pause for this one. Go ahead, Aniket. Please ask your question.
Thanks, Arpit. So, continuing the discussion that you were having with Saurabh, right? So, there are cases where you don't need a deterministic workflow, and that's where, for example, we are evaluating a MuleSoft agent framework, agent fabric, where you have an agent card, multiple agents are registered as an agent card, and then on the fly, it decides which agent to call, right? So it's not a deterministic workflow, but you have a catalog of agents where it gets decided which one to call at what point of time. Right? So that's where, they are using A2A to do that, but that's where I was trying to understand. It's not deterministic for workflow that is always needed. There could be dynamic calling that might be needed in some cases, or most of the cases, because now
it is still deterministic. As I gave the example, identify language. Based on the language, you call different agents. It's the same thing what you're doing. So it is still deterministic because the number of agents that you can call is fixed, and also in a particular request, only one of them will be called. It's not that I will reach a decision point and then spawn hundreds of things. It's always I will reach a particular point and choose one of the possible options.
Okay.
So my workflow will only behave in one of the few ways, depending on the number of agents I have available.
Okay, probably I will continue that discussion once we are done with this.
Yeah,
So
perfect.
probably after 11.
Thanks, Aniket. Yeah, thanks, Aniket. Okay. Next up is Critic Refiner. Now, no more prototypes. We'll directly go into system, but I have 3 more topics to cover. So first is Critic, like how we saw Orchestrator Specialist. Similar to that, there is one more pattern, which is Critic Refiner. Fancy word for you to just revalidate and critic what has been outputted and refine if required. For example, where the whole idea is whatever is the output of the first agent, you have a critic in it, which is critiquing the output. That, hey, for example, the article that this agent done, now this is not just one LLM call that is critiquing. This full agentic loop, the final output, which is, imagine the deep research agent, deep research report is not in the format that we write. So this is your critic. So not critic. This is your main agent that wrote the article. Your critic writes it. Critic critiques the article. Find slow queries. Critic critiques the article. Why did I write this? Critic critiques the article and refiner then refines it. Because now imagine your refiner in case of article is someone who knows how to write the markdown file, or how to structure, or how to format the markdown. Or this is simple formatting. This could be another which is taking a look at into factual consistency of it. Because a critical is finding the flaws and refiner is refining basis the findings of the critiquer to do it. So refiner is just a doer, critiquer is critiquing it. Like, hey, is this factually correct? Now this critic can be its own loop. It does web search to find factual correctness in that. Similarly, SQL query optimizer, critic can find slow queries and then refiner can optimize it. Again, the lines are blurry. You can say ki, oh, my critical is also refining the queries, and then your refiner might just go and like validate it. Again, it's all English at the end of the day. The idea is to have whatever is the output of an agent, if it is sensitive enough, critical enough, you may want to make it take a second look. That's the whole idea. Right? Okay. This is a critic refiner, very similar to what we discussed in first week, where we had this thing around reevaluating what is output when we were doing this fact checking system, where we relied on self knowledge. Now imagine instead of self knowledge, you make tool calls and do web search and check if it's all correct. Now that is its loop. That's why I did not have the prototype for this. So you add this where your correctness is more important than speed. That's the most important part, because now once the output is generated, having this additional loop is costly. It's time consuming, it's token consuming. So where your correctness is of utmost importance, you would want to spend more tokens, do more iterations until it's refined to the best that you would want as an output from this agent. Then you have another, which is mixture of agents. It's very similar to what we discussed, mixture of what something we discussed, where you make the same task, you give to multiple agent, and then you combine the result and give the best output. So imagine you give deep research agent, like you have deep research agent using Kimi, deep research agent using Claude, the deep research agent using Gemini. And then you have output, and then you have a synthesizer phase which takes all these three reports and creates the best version of it. On top of it, now you can have a critic refiner if you want. So it's not this or this or this. It could be combination of it depending on what you're building. So there is no one way to do it. Remember, this is not just one LLM call that we're talking. This full agentic loop that is doing a deep research. It's not just one. It's full agentic loop that doing. Second agent doing the same task. Third agent doing the same task. And you either picking the best of them or you combine all of them and generate a final synthesized report. These are a mixture of agents. Again, you see, it's only done by people having a lot of money. If you don't have money, you are okay with the output, good enough. Right? Which is where eval comes at play. Next week, first thing, we discuss that. And then the interesting one. This is something that I have suffered very poorly, which is deadlock in agents. Yeah, OS chapter number 3 again. Deadlocks. So chapter number 5 again, deadlocks. So now imagine this, you have multiple agents and your agent A produces an output that goes to agent B, and agent B decides that whatever I'm doing, it needs to go to agent A. The same thing. And it's stuck. It keeps sending here, and nothing comes out of it. I'll give a concrete example of it and how to fix. Of course, same OS concepts comes in handy. Now imagine you have two agents. One is refund agent, one is shipping agent. Right? Customer is asking for refund on a damaged item. And there is a text line written in the agentic loop prompt for refund agent, which says, if the item was damaged, escalate to shipping agent for fault confirmation before processing. And on shipping agent, you wrote, if refund is requested, confirm with the refund agent that the refund is approved. Because imagine the engineer in the team decided, if the refund is not approved, why do I even need to check? As a quick short circuit evaluation. And that would lead to what? So if refund is requested, confirm with the refund agent that refund is approved before logging for the shipping fault. Now, because these two agents are owned by two different teams, and if someone wrote this and you wrote this, so what would happen? It would go over here, it would hand it off here, it would go over here, it would hand it off over here. So that's why you have to be very mindful when your agents are distributed. Super mindful when agents are owned by, let me be specific, owned by different teams, and you can hand off to each other. You don't want to end up in a situation where this deadlock. If there is a deadlock, how do we fix it? Simple. Cap the number of iteration count for any loop. Very simple. Because then there is a potential deadlock that would happen, right? Or you can add an explicit convergence criteria that, hey, if you are in, let's say in an orchestrator thread, you may write, if you're going to again to refund agent or this and you see this happening again and again, block it or cancel it or return something, right? Or you can decide that if it's going more than 2 times explicitly, or you say, ki, hey, if you cannot decide, then just assume that you have to give a refund. Right? Or you have a supervisor, this is your orchestrator part, or you have a supervisor agent which takes a look, hey, what are you guys doing? Now imagine, what is this supervisor agent running on? The input to this supervisor agent would be, imagine this agent is exactly solving one ticket, one ticket that is raised in your system, which means it would have a database entry. The agent delegation that it did, it would be logged somewhere in a table. So imagine there is a supervisor agent that is running, which is polling the database, making a simple LLM call and say, do you think there's a possibility of a deadlock? As simple as that. Or you can do it deterministically if you detect like cycle in that, right? You can do it deterministically, you can do non-deterministically with LLM. But the idea is that, do you see a risk of running an agent? So this is literally a simple process, simplest example, which polls the DB, queries, checks for deadlock, be done. This is what it's short circuiting the entire ticket resolution agent. Your life becomes simple. And that is what we should do. Do not unnecessarily make things complex. Like that's why these are the things where these are the common production pitfalls that people run into. So just be mindful. Don't like take everything with a pinch of salt when you are dealing with LLM, because it's fully non-deterministic, and worst case it's English. So it's subjective to interpretation. So hence your prompt needs to be super unambiguous. Right? Perfect. We have one thing to discuss, which is system. We'll take a break and then we come back, and after system we'll discuss again. Not very huge, but this has some interesting nuances that I want to touch upon on building incident auto remediation system. Right? So it's 9:56. We take break for 10 minutes. Oh, sorry, 8 minutes. We come back at 10:04 and we resume this discussion, right? With this system, and then we take questions all together in one shot. See you folks in 8 minutes at 10:04. Awesome. It's 10:04. And now we start with the system where we design an incident auto remediation system. The idea is when you get an outage, now a lot of companies are actually trying to build this, right? So when you get an outage, by the time the on-call engineer comes, you should have the first set of triages ready so that your life becomes simpler, right? That your on-call's life becomes simpler, and your incident triaging system should also recommend commands to run, etc., etc. Now, over time, the companies first, it will always be human who will be executing it, but once you have high confidence, you would see agents automatically taking actions for high confidence triage that has come out. Right? Now, what we'll do is we are trying to build this system, so we'll look at it from the lens of system design. Right? And the agent loop, we saw the drill, how it happens. So if you look at it, what we always covered in this course is the fundamental patterns. Now we're just using them together to solve a problem. So essentially now you'll see how this is all just a regular classic LLD, HLD or system design problem that we have all solved always, but with just sprinkling of AI. So we'll take concrete numbers. What we'll say is we have 5,000 alerts per day is a steady state. Right? We have to do time to first action. P99 will be 90 seconds for a P1 result or P1 incident, 5 minutes for P2 incident, 15 minutes for P3 incident. Imagine what you're getting from the systems which is alerting and sending you alerts like say Zenduty, PagerDuty, Incident.io, etc. They all come to you via webhook. That is becomes an ingestion. Right? And from there we proceed and put everything out. So idea is to first focus on your triage report on steps that on-call can take to output this. Now here you will start seeing like how system design comes at play and things that we have to worry about, that how robust the system is, because if after AI does the triaging, if you have to take subsequent actions, that should be very apparent, right? So here these kind of systems, what I felt, improves your overall empathy in the system, like how you design the system. Right? One simple example that I give, which is kind of a spoiler, is to imagine linking all the critical references in your triage report so that user does not have to go through internal documentation again and search for it. Make it everything that you're giving as a triage report has everything in it, so that you don't have to look for pieces of information elsewhere. Plus, it's not just that, but also this citations acts as the place from which this output or this agent got its information. So in case it refers to something which is outdated, you will flag it and that becomes your feedback loop into your system. I'm just giving few spoilers and few things to worry about, and why these kind of systems, it's about how you are structuring the information. Agentic loop, that reasoning, etc., RAG, this like classic RAG and reasoning system that we are doing. But around that, what we build is what we are discussing. Fair? Okay. So we'll start with the first thing. I'll start with functional and non-functional requirements. I'll quickly go through functional because non-functional onwards is interesting. So functional requirement is system receives the alert. What each alert contains is important. Right? Now, what we are expecting the system like Zenduty, PagerDuty, everything else giving you in that alert, which is more importantly, it should give you priority of the incident. Because when you configure an alert, you would know what priority it is if you can. If not, every alert becomes equal. Second, it gives you incident life cycle. Like what does an incident life cycle, it not to give you, you have to decide on incident life cycle because it's very particular to an organization. Where if I'm saying this incident, is it snooze, is it retried, etc., or like it reappeared, etc. And it is in fixing, in triage, AI triage, human approval needed, etc. So you have to design that state machine around it on what your incident lifecycle typically looks like. So for example, you may look at this system or any other system who has built it and say, hey, this is the exact same flow I want to copy. But you should not do it. You want a system like this to integrate in your existing workflow. You cannot change your workflow because an AI solution exists. Because if your company, your team is used to operating in a certain way during an incident, it cannot change overnight. So think of it as think of it as augmentation, not as a replacement. Right? Hence, most of the AI system augment, not replace. So most of the AI systems that we see, people try to replace their existing scheme of things and say, hey, this is a better way to do it. I'll replace everything. But the thing is, then it never gets adopted, then feels like a forced adoption. Right? Okay. Another thing to worry about is remediation action that we're doing. That is the most important stuff that we have to do, and verification. This is the ultimate thing. That's where your critical refiner loop and your fact checking stuff, all of that would come in handy. That more about a critical refiner, that whatever I'm suggesting is true to its needs. Fair? Okay. Now let's get into non-functional requirements. So in terms of non-functional requirements, I'll ask a concrete question. Imagine I'm getting, keep a calculator. If you want to keep a calculator ready, keep a calculator ready. If I have 500 alerts per day is my steady state, what is the number of alerts I would get per second or per minute? Let's start with that and then ask a lot of probing questions on that. Whoever wants to chip in, raise your hands, calculate this, and we'll start the brainstorming around this. 5,000 alerts is 5,000 alerts per day steady state. What is the peak load? What is the average load? How you'd want to deal with that? Pratik?
Yeah, so I think I did calculation by hand, so I think it's around 3 to 4 seconds. 3 to 4.
How many? 3 to 4 per seconds?
Yeah.
How many seconds in a day?
3,600.
3,600 seconds in a day?
No, wait, what? 60 seconds, 60 minutes,
In a minute?
3,600. Oh, into 24. So
That's why, right?
70.
0.00
Okay. So then less than 1. Yeah.
less than 1, right?
Yeah.
So now if it's less than 1, I'll take a concrete number, which is, let's say it is, where did it go? Okay, which is 0.006 alerts per second,
Yes.
right?
Yes.
0.006 alerts per second, right?
Yeah.
So is this your peak concurrency for this system?
This is my average concurrency, right? So
Yeah.
now my
What would be
peak,
the peak?
let's assume in the worst case scenario, everything going down, we can say 10x this, but it's still less than, like, our peak would be 1 to 2, maybe. That should be our peak.
That's it? 1 to 2 alerts per second.
Yeah. Based on 0.006 alert per second,
At an organization, you would not get more than 5,000 incidents in a day, even at a, like, not at Amazon scale, but at a decent organization scale, right?
5,000 is very high. Yeah.
Exactly, right? So even for 1,000 alerts per day, you're saying your peak alerts that you would receive in a system is 1 to 2 per second.
Okay.
Peak at that second, peak number of alerts I'm getting. No, right? Because when one goes down, you have cascading effects.
Oh, okay.
You mentioned it. You mentioned
But I'm
it.
assuming that there is, okay, we have something called grouping where if one goes down and they're cascading, we
But
just
then
get.
all of this, correct, but all of this is coming as a raw event from incident
Okay,
diagram.
okay.
Correct. So you would still get those events. This means that you need not act on every single one of them.
Act on everyone, yeah.
This is super important. Otherwise, you're just wasting your tokens and your entire compute infra. Because if it's a cascading effect that has emerged, you have to have that grouping logic that typically these tools have. If they send you raw events, or if multiple systems are that you're integrating with, you have to know that these are related.
Yeah.
And if I fix this, then I take over. So that is one of the important choices to make, right? Okay. So I have 5,000 alerts per day. Peak certainly would be, let's say, 50 alerts. And you group it, then it would have like 2 to 3 unique incidents that you're dealing with. Let's say 3, right?
Yeah.
And then you would want to still scale it, because if, let's say, 3 different systems went down due to one reason, it would be difficult for you to group them under one, because you have to treat them individually. You multiply it by, let's say, 10, so roughly 30 worst case peak you would want to handle at one runtime.
Yeah.
Okay. Now, given this is what we're dealing with, what your very high level overview of this system looks like. So you typically have your pager duties, Zen duties, everything else of the world. They're sending you over webhook, you ingest it in Kafka, and then you run it with your executor. These are classic standard day zero architecture for the same, right? And this is where our agentic loop runs.
Yes. I would also
Okay.
split based on priority.
Okay. The splitting based on priority. So you get it into different Kafka topics depending on the priority.
Yes.
Great. Then your executors will be per priority based.
Yes.
Okay. What does information your executor needs on runtime?
So logs, metrics, code references, so the GitLab repo, and I'm guessing so how we configure PagerDuty is we have each PagerDuty alert containing this information along with opdocs. So
Yes.
the alert has an associated opdoc with it. So that comes, so I'm guessing all of this information is flowing. Metrics will obviously have the Grafana alert because of which it is failing. So it will go look at that particular dashboard. Code will just be the GitLab reference to the, or the GitHub reference to the code base. Logs is basically, I know the pod or the namespace in which it is failing, and I can go to the application or deployment for that. This one other thing I would need is memory in the system, because this is a great system to actually learn from what has happened in the past. And for me, this system should then store memories of incidents that have happened in the past and then use them in the future for more incidents, similar instance that.
And also improve your opbooks.
Improve your opdocs as well. Yes.
Right? Okay.
Yes.
Now, one of the most important one is deployment.
Yes.
Because very likely most incidents happen because of a recent deployment. So
alert,
if you
yes.
check there's a recent deployment that has happened, your first remediation step would be to going back. Okay.
Yes.
Now, where is this entire correspondence happening?
What do you mean?
Now, what is this executor doing? Like, where the output of this executor is flowing?
So the executor output is flowing to basically different integration points, right? So one easy would be I write back to the PagerDuty itself in comments, whatever this is doing. The other, what we have or what we are trying to build is Slackbot integration. So it sends a message to the channel on which the PagerDuty incident comes, so that we have the on-call in the loop on what the agent is doing.
Or a classic Jira ticket in case you
Jira
create
ticket
one.
also. Yeah.
Right? So typically every organization has a place which has a thread where entire correspondence happens. Right?
Yes.
Typically Jira, if you assume, then Jira or Linear or whatever. Right?
Yeah.
So we need essentially this entire triage is one place where that on-call person is coming, because you don't want to change the on-call person's behavior that, hey, now you have to log into a different portal.
Yeah.
So this connectors needs to be there, which could be internal tool calls. Right?
Yes.
So whenever an incident happens, you need to have a database which holds this entire set of information, which says, this is my incident message, this is my incident ID, this is the description of the incident that I have, and this is its relevant Slack thread, or your PagerDuty ID, or your Jira ticket number, so that it becomes easier for your agent to make a tool call and add correspondence to it.
Yes.
Right? So all of those will be tool calls.
I would say how, like as I was mentioning, like in PagerDuty configuration, we add all of these things. So in PagerDuty configuration, there is Slack. In PagerDuty configuration, we have all the additional stuff that you, because even as a developer, if I'm going without an AI also, it helps me out on finding out these things.
Yeah.
So yeah, I would keep it there instead of a separate database, because then the database can go stale.
Yes. But again, you would need that corresponding reasoning trail so that you do debug, observability.
Yes.
This could be, so again, this database would help you drive your memories.
Oh, okay. Yeah. Memory anyway, I wanted to keep a separate database. So yeah.
So again, all of that would flow into the system. You could use Postgres with PG vector extension or whatever to then take a look at it later and improve on your opdocs and runbooks, etc. Right? Okay.
Yes.
Are you happy with this overall flow? Like we discussed at very high level, and it has a lot of tool calls integrated. Anything specific that you would do apart from this?
One thing is having an alert on this system, because this system is obviously our own thing. So if our queue size is becoming larger, then we obviously might breach the SLAs that we have in terms of response time. So if like we get multiple P1 incidents at the same time, and our time to process each one is maybe 30 seconds, maybe 40 seconds, then we might not be able to solve the third incident within the 90-second time frame.
Correct. We have a P1 pin 90-second within which we have to output a try-edge, which means your average latency should be within 30 seconds.
30
Now, within
seconds.
30 seconds, how many LLM calls can you make?
Max 5 to 6.
Sequential.
Max 5, I would say.
Sequential.
Yeah, sequential. Max 5 sequential.
Max 5 sequential. And in parallel?
Parallel, I can make any number. Like again, if there is if everything is in parallel, then just it will take 5 seconds, 6 seconds for me to complete all of them. So
Okay. Now, given you can make 5 sequential calls, right? So assume if you have assume you have like 4 or 5 agents running, which means each agent in its sequential iteration can make in 5 LLM calls. It should be able to deduce
yes,
what it needs, right?
yes,
So you do not have more than that, which means now your system prompt, your user prompt that you're passing, that needs to be sharp enough to output this. All you have is this 5 or even let's
yes,
say double it. Let's say 10 LLM calls per agent. That's why we cannot do all of this agent calls, like all of this calls to, let's say, if you're doing with a critical agent, which goes and like one agent that takes look at your logs and tries to deduce, one takes a look at metrics and tries to deduce, one looks at, let's say, code and tries to deduce. They cannot have more than 5 to 7 to 8 iterations in order to come up to this final piece that, hey, this is where the root cause lies, right?
yes.
So, but all these agents can run in parallel, which means you need to have this provisioned capacity of 5 into, let's say I have 3 agents running in parallel to do this. 5 3s are 15 calls in parallel is making for one incident.
Yes.
Right? Given that you are getting roughly, let's say, peak pay, you are getting 30 incidents, or not 30 seconds, no? 1 to 2 alerts at scale. So let's say 10 you are getting. So you would be making roughly 150 LLM
150.
calls
Yes.
during peak time. And again, given LLM calls spans a certain duration, there will be some interleaving, but 150 LLM calls peak, LLM calls in a second.
Yeah.
Peak. In a second is what we'll be making. So which means this will constitute your top level LLM rate limiting that you are having. Typically, one of the things that we don't appreciate enough is, imagine you are a big company, imagine Amazon. And at Amazon, imagine that an outage happened. And the system that deals with this outage, that alerting system that deals with this outage, or the system which raises the alert, raises the pager duty or whatever, that itself is unreachable or is down. That is problematic. So here also, given this, applying the same concept over here, to make sure that you have enough capacity, enough rate limits, that at peak time, you should be able to make calls to LLMs. More importantly, have fallbacks.
Yeah.
Because if, let's say, Gemini is down, what do? You cannot say, hey, I cannot fix my issue because Gemini is down. You need to have fallback, which means your agentic loop cannot be a model specific. It has to span at least 2 providers. At least 2 providers. I'm just making notes here as well, right? It is span at least 2 providers because uptime of this is important. Apart from the uptime of the infrastructure that we typically discuss in system design stuff, uptime of LLM, like having that fallback, is super important, and having enough capacity, enough rate limits is super important. Typically, you might just want to use a separate account for this, if possible, or you want to use a separate key depending on how you're negotiating your contract with your LLM provider. Okay. Again, these are decisions that people typically skip. I'm just trying to highlight that this is nothing but your harness, like how reliable and robust your harness is. Like other loop, so you can write, but these are the stuff that we typically don't think about. Right? Awesome. Thanks, Pratik. Anybody else who wants to chip in for the next part, where we discussed functional requirement, we discussed keep things to keep in mind, and we discussed number of peak LLM calls, right? Now, capacity estimation, we'll take a look at it. Very simple calculations we'll do capacity estimate. Dipesh, with respect to capacity, given I'm dealing with 10 incidents max in parallel, max in parallel, we certainly would not need to worry about database. Do you think we need to worry about database at all? What do you think?
No. So Arpit,
Hmm.
one thing here, like as you are building this investigation agent and it's dumping the whole investigation in a doc, right? For
Hmm.
the on-call person. So do we want to keep some sort of stepping limits, right? How many steps you want to go your agent to go deep in, right? Because it's possible like the skills
You are
you
always limited. That's what we discussed, right? You're always limited by. So your steps, your LLM calls that you're making, it cannot go beyond 5 steps. So which is why this number is very important.
Okay, understood. Yeah.
Right. So this is your multi-reasoning step that you are doing. Right.
Right,
That
right.
number is very important. Right. But now you're talking about we are not dumping. So one very important thing is given that all this information will be consumed by what your on-caller, and on-caller let's say goes through Jira UI. On-caller let's say goes through Jira UI to do it. This information cannot be very confusing. You cannot give like massive prescription that it takes time for him to read. You cannot just output what Claude outputted as is to that, right? Give them very succinct thing. This happened, this is the command that you run that would fix this. Then you run this command, then you do this, then you do this with hyperlinking in place. So do not unnecessarily keep things verbose. This needs to be very crisp and short. So this is one of the most important things that you will provide in your LLM prompt. That the triad that you are posting cannot be too verbose for your on-caller to go through, because by the time on-caller goes through it, gone. Right? You cannot let that happen. Okay.
Yeah, understood.
Dipesh.
Thank you.
Dipesh, apart from this, right?
Mhm.
You said large amount of data. We are putting every correspondence in database. Don't you think database will have too much data? Can you calculate? Make a rough estimate of it.
Yeah, if you're like putting the whole doc in the database, right?
Which doc?
The investigation doc.
What is investigation?
Or
There is no
maybe the
investigation doc. We never discuss investigation doc. Are you talking
the
about
context,
OpDoc?
right?
These are run books.
Yeah, not the run books, the context of the 5 steps which our LLM has done, right? So if you want to give our on-call person a handy run book or
Would you?
a
This is not
page
run book,
of
right? These are not run books are separate. Run books are already defined steps for you to do things. Correct? This is just what LLM did. You don't want to expose everything to on-call. On-call is already frustrated. He or she woke up in the middle of the night to fix this. Don't overrun. Correct? This data is like every single step, every single output, every single reasoning should not be visible to your. If they want to, they can exploit. But I don't think on-call would ever do that. On-call will try to just fix it as fast as possible. Correct? And then go back to sleep. Right?
Yeah.
Right? Okay. Any other considerations? Let me ask a very specific question. How will I generate my first triage report for my on-call agent? So we discussed multi-agent where each one goes and figures regular metric, etc., etc. Let's say once it got all the response, now what? So what all things it is calling, we kind of have an outline for that, and then how it is synthesizing the information, and what are the important things you provide in the prompt.
Maybe the one thing I think of here is like which alerts are actionable, right? Which alerts requires action from any human.
So all of that can be happen at deduplication at this level, like at this level. So actionable, grouping, etc., etc. All of that will go over here.
Okay.
Then what all things is executor looking at? Code we discussed, metrics we discussed, right? Logs we discussed. How is it going to check runbooks?
Ideally, yes. If one of the alert it's like they don't know, right? So they have to go to runbook to see
how is it going to runbook? How is your agent going to runbook and checking it? Where is the runbook? There are thousands of runbooks.
We have to build a map of it somewhere, right? With type of alerts, which runbooks should be referred for.
But what if that runbook does not contain the information, but some other runbook contains the information, right? You can't just rely on one runbook. What if organization starts with 0 runbooks or has very limited set of runbooks? Because and what if, worst case, you saw an issue which is not tagged to a runbook, right? It's a fresh issue. Then what do you do? So it's an open-ended retrieval problem, right? So this is where your RAG system comes in. Your entire RAG system that we discussed, this is your vector database. You need this, where all the runbooks are indexed. And your agent makes a RAG call to get the relevant stuff. So this is another lookup that you would do. You'll find everything that is relevant, right? So our entire RAG system that we discussed, copy paste over here. I just replace it with the vector database. Okay? That will be required. So once it has all the information, now what do? What is your key things that you provide in the prompt that provides you a output for it to fix? How? Let me ask simple. How does a prompt look like, Dipesh? They'll say, what, Arpit? Given all this information, give me steps to fix it. Right? You could start something as simple as this.
Yeah, understood.
Right? But what's the next level? Is it good enough? We saw so many prompts. And we are being oddly very specific. Right? We go to Kevin. Wait, thanks, Dipesh. Kevin, how does my prompt at executor look like? So it just made all the tool calls, gathered all the information. So it created sub-agents, went, gathered the data. Orchestrator has everything. Now it needs to dissect. It needs to come up with a triage. What do I do? What do I write?
Yeah.
What are things I take care of?
Yeah, so basically, like we're thinking from the perspective of an on-call engineer who's going to take a look at it, right? And it needs to be very crisp and clear, and what actions they need to take. So specifically, if the agent is going through all the runbooks and then all the matrix, the logs and all of that, right? So then one thing that I can think of it, like if it has like some deterministic knowledge, like what, so then the first step would be like, providing a brief description of what, the description of like, this is the issue and this is the potential remediation, and mentioning about like how it came up with that information. So it could be like a query to your logs, like what query it ran, and then it got that information specifically, pointing to the specific runbook, and also providing, let's say, if it was a particular deployment that caused that issue, then
but it would not know, right? It would just give you a list of past deployments on the service. So now it's your logic to say in past what time? 5 minutes, 10 minutes, or you say past 5 deployments and pick, do you think it could be the issue? So it would say, what are the chances that it happened because of a recent deployment? Your LLM is smart enough to figure out that the deployment happened last week. It cannot happen. It cannot change anything today. But imagine you have a change flag. You have a feature flag that got flipped.
So based on the logs, right, it can potentially, if there is a specific change that happened and that triggered this issue,
but
then
see,
potentially it
you
can
have
flag.
deployment, you got past deployments. Deployment happened 2 weeks ago, but your feature flag turned on today. So you need to infuse your feature flag as well into this, that audit history of feature flag. Fair?
Can you repeat one more time? Sorry.
Feature flag, you know a feature flag.
Yeah.
Deployment happened 2 weeks ago. LLM will
Okay.
say this is not a cause of issue. Correct? Because you you changed the feature flag today. You turned it on today. The code was live 20 days ago or 2 weeks ago. Right? But feature flag turned on today. So today it went live to all the users. So that log also needs to be there.
Right.
So audit history of feature flag relevant to this service. Now imagine now all the metadata that you need to hold for a service. These are relevant feature flags for this service. These were the feature flags that were used in the deployment. All this information needs to be consumable. It should be in a consumable format by our agent. That's why people say your agent is as good as the information that you provide it to. The better the information you provide in a better format you provide, smarter your agent will be. Right? Again, I'm just opening up different possibilities. You'll say, Arpit, what is like, why is this system so 10,000 feet view? But these are the things which is like very AI related. Like, what are we providing for it to proceed? And these are the unknowns that we have to think about. And this is where our intuition typically kick in. Right? Okay. So you wrote that prompt, it outputted. One of the most important things you forgot to provide this as an input. So you provided tool access to get things. You provided vector database with runbooks, right? You forgot one super important thing. Other two very important things.
So would the system act remediation, or are we saying the on-call would do the remediation?
On-call will fix it. Okay, wow, okay, great question. What will you prefer?
Depending on the severity and potential of the issues that have been happening, based on that, some of them, if the confidence, right? Essentially, if we are confident on certain low-hanging issues, then potentially those could be remediated by the system based on the history. And if there are like high priority systems, then you would want your on-call to take a look at them. So
you should always want,
these are
but imagine this, your on-call is anyway going to be there for an incident, right?
Sorry?
Your on-call will always be there for the incident when the incident happens. This is just aiding it. This is assisting the on-call, right? You don't want AI to take actions without a human because it's outage.
Even if they take action, right? I mean, it will be more like, let's say if it's a PR change that they need to make, they will, the agent will create the PR, but still the reviewing would be
of course.
human.
You're assuming PR. I'm assuming database config changes, feature flag reversal, right? All those actions are also there. You're assuming it's code fault. I'm assuming it's subsystem faults.
Even if it is a config change, that can still be a PR.
Do you have a config? You're assuming your config change is a PR-driven change. I imagine you have a config system that has an MCP tool expose which allows agent to flip any bit that it wants. Right? Problem.
Yeah, that I would get, because that you wouldn't want to do that.
Yeah. Hence, the idea is by the time person comes online, all the critical information that it needs to take action should be there, because the person is there, is attending to it, right? The person can take actions. Yeah. So I'm just saying how severe, given its outage issue, because if AI messes up something, you go berserk, problem, right? So that another thing that we should add is past incidents that has happened. You do a semantic lookup on that or a cosine similarity on that this is a similar system had happened, and what steps agent took. There should be one more agent that is running from this when an issue comes that says similar incidents that has happened in the past and actions agent took.
That's what memory is.
So memory, but
I'm going into that.
Even like runbook, we kind of mention. So runbook has these past incidents, right? So there.
Not
so
always.
We do. So
runbook has
we
remediation steps.
No, we have two runbooks, right? One runbook is remediation, and one runbook is essentially the on-call has kind of kept like the past incident record, like each day, right? So that is that I would consider still as a runbook. So
of course, if you have it, great. I'm just being explicit, right? Okay. Refer to your past systems and how agent tried to navigate, what steps it took, so that agent has a guiding light how to proceed with that, right? Rather than it hallucinating in different direction, it can leverage that, but it has some weightage, not full weightage. It has some weightage for it, because it could be there that we don't want it to take the exact same path. It would be a different thing. So it still needs to be reasoning. It still needs to be a reasoning loop. But hey, you might consider these steps, but feel free to take differences if you feel like. Kind of this. Okay? That is an important thing. So that this way, you're still letting it converge a bit, you're guiding the agent a bit, but you are not forcing agent to take the same path, right? So because it is an exploratory use case, it's still a reasoning use case, right?
Yep.
Okay. Next up, the second important part is format or style of triage. So ideally you should have how the tonality, that structure, the command, how it needs to be formatted if it's written in a very similar way across or there's a less cognitive load. Right? Again, I'm just making the life of my on-caller simpler. Right? Okay. Now we'll go to the next part. The next part is something which is highlights of this that we have to worry about, which is your remediation actions can be irreversible. For example, if you are doing a pod restart, it's an irreversible action. Once you trigger the restart, you cannot do it. The reason is why I'm saying this is because should you let your agent take these actions or not? That's the point I'm debating. Because there could be reversible action, there could be irreversible actions. So now for all the actions, for all the MCP tool definitions that you have, add a flag which says if it's a reversible or an irreversible action. And then you can have a staggered rollout and say, hey, if this is a reversible action, I'll let my agent take. If it's an irreversible action, I won't let my agent do it. Okay. Then next up, capacity planning we discussed. This is very simple. The same calculation that we did, the number of LLM calls that we are trying to make, etc., etc. Storage is anyway never going to be a problem over here. Never. It's going to be peanuts, right? Whatever we are storing. Now, this was high level architecture we discussed. All the access that it needs is what we have. Okay. Here, one interesting calculation. In 90-second span, that was our P99 for a P1 issue. So in 90 seconds, we have 90 into 10. 10 is a peak alerts that we calculated that we would receive. In 90 seconds, worst case, we'll get 900 incidents. Some of them would be redundant, agreed, right? What we need is, let's say if we assign one incident to one server, then we'll need 900 servers to do it. Problem, we don't need this. Hence, the deduplication logic is essential so that we don't deal with 900 instances, right? Plus, even if we have to, worst case we have to, given all of your use cases IO bound, not CPU bound or memory bound. It's still memory bound, but not CPU bound or most of this is LLM calls that you're dealing with some memory, and you can still offload a memory to external storage. You can have one core per incident. So if let's say you have a 4-core machine, right? You have a 4-core machine, but it can handle 4 incidents. So this way you slash your number of servers requirement to 225. But it is still large, but that is peak. And if you do deduplication and all grouping, etc., you can bring it out even further. This is the worst case, absolute worst case analysis that we are doing. That's where your short circuiting of your incidents is essential. If you think that, hey, it's not worth it, I'm already solving an existing current ongoing issue, which is on the similar lines, I will I'll kill myself because I know it will be done by someone else because some agent is already working on it, right? So then that's one of the things that we have to deal with. So roughly 80 to 100 servers is what you would need. Okay. Now let's look at very high level architecture of this, and then we'll look at human taking action. So you have your PagerDuty and ZenDuty coming in. Again, I'm using Jira as my entire ticketing system and correspondence. It can change depending on organization, but you can use PagerDuty or Incident.io or whatever to do it, right? Now, whenever you get alerts, your information goes in over here. It first creates ticket, etc., etc. That's by default your integration. Then it goes in. Here your deduplication happens. Now, what is the deduplication logic? The deduplication logic is for this service, for this condition, because the alert is always raised for a condition. For this service, for this condition, if something is already in progress, you run it with a TTL of let's say 1 hour or 5 minutes or whatever, then it does a deduplication over here. Once it filters it out, then it goes into Kafka. From this Kafka, the executor picks up. Then from here, you have your Postgres, where your memories and your state management, your incident state management takes care of. This incident is triage done, this done, that done, etc., etc. You take care of this. Then you have your orchestrator, which is essentially scaling your queue, scaling your consumers and executors depending on the queue length. That's what it does. These executors have access to metrics, log, deployment history, runbook index, code, And another thing that we discussed was feature flag and similar incidents. And depending on this, it runs your loop. It runs whatever you would want to do. Multi-agent, because you would be checking this in parallel, right? And within that, you would have your reasoning steps to reason until it converges. Everything should have a max step attached to it. You cannot go beyond 5 to 7 LLM calls, or within that time. Time is a better thing. You cannot go beyond that to come up with your diagnosis, right? Okay. Now, what executors output also goes as correspondence. So now this would need to have connector set up with this Jira so that it adds that correspondence. So the idea is within 90 seconds, if I have my correspondence over here, so my on-caller can take a look at it. Now, given this is just initial triaging, which helps this on-caller issue, like fix the issue very quickly. Now, there are two important things. First thing is that this is not the end of the job for my agent. This is not the end of the job. Because given that this guy did so much of heavy lifting into figuring out all the important stuff, creating citations and links, citation and links and hyperlinks and everything, this on-caller should be able via a chat. This is the same database. This Postgres and this. So imagine executors continuously pushing the state over here. So given this, it did a lot of heavy lifting and kept updating, kept the state updated. I should have a simple chat interface with the same set of tool integration that on-call can talk to using the same database as this one and continue the chat. Given all the context that it used to generate this first triage is already loaded, and then can pull it more if required. So this becomes your standard chat-based interface, which is essentially your RAG application, which is figuring out what it needs to build, how it will be, what is relevant, what needs to be done, etc., etc. This is standard RAG implementation. Again, add vector database, etc., etc. That entire downstream subsystem as is. That's one. Second important part is whatever this triage it uploaded over here in correspondence. Again, as I said, this job is not done of executor. Your triage agent should keep running in background and should critique whatever is happening. When a user adds a new correspondence, your triage should validate, is this correct? Or why this is happening, it can continue doing its own exploratory analysis on the same set of stuff until it finds that out. If it finds out, because all it did is first 90 seconds, it did help you triage. But what is a long-term fix? If you need any help, that's first is chat, but it can proactively push what it found by redoing this analysis or digging deeper. This is where you use a different model and different ways. Now here you can just use low-hanging fruits. You can move this code part to critic. You say that my critic will look at code and again all these metrics again, but code in much more detail to figure out what has happened and will help you raise the PR or help you change the PR, or if the PR is created, will help you modify it and review, not just review it, not code review, but critique the actions that you are taking, because you will keep adding your correspondence. This critic is adding its correspondence on this part. Now, depending on how sophisticated you would want to make, you would choose to add a critic. Right? Okay. Next up. Now here what has happened is we wanted, up until now, this user is taking all the action depending on what is written over here and is using his or her own brain to decide what action needs to be taken. But now imagine if you want AI to even execute. If you want AI to even execute, then your executor nodes, here what I did, I separated a few things out. I do not want this executors to also execute directly when it's triaging, because my first step is to figure out the root cause, help on-caller, and because most of the stuff will be taken care by on-caller. But if I want AI to execute, I would never want that AI to execute ever, right? But if it's no action, imagine on the correspondence, you have a button which says run and the command is given. You press that run button and it runs it. Right? So think of it as human in the loop implementation, which fancy word, but imagine I would rather still implement it as a API call, where in my correspondence I get this run button which says take this thing and run over here. It doesn't require agent to do it, right? So it literally just makes an MCP tool call to an executor. This is your command. Let me give a separate name. This is your command executor, which has connectivity to K8s, AWS, internal feature flag, all other subsystems, and can run commands. So the output of what you got in your Jira correspondence out of your critic and your correspondence, the command, it could be shell command, it could be a simple MCP tool called invocation. So that command execution, I should not be having to log into a server to do something. It should be done via this executor node. So you define all the tools that requires you to fire bash commands. That's it. If it is used to fire a command on a particular instance, which abstracts out creating of of SSH connection to that server via bastion and fire a command, get the response and do it. Fires a command on, let's say, deployment tool, fires a command on, let's say, some other system. Let's say you would want to take down your auto scaling group. If it figures out the step, then you can just have a, let's say, a highlighter. You select the text and say run it. That goes via MCP tool and it executes over here. So this has access to all the system, right? And it runs the command and it exposes the MCP server for you to do it. Now you can be as creative with this as you like and say that, hey, I want to execute, let's say, deletion of this auto scaling group. You just say in natural language, it's written in Traj. You pick that and you say run as MCP tool. Your incident auto remediation agent asks you which auto scaling group you want to delete. You copy paste the name and say delete this one. It makes a tool call, waits for human in the loop for you to take that action, and then you run it. So what I'm doing is I'm making life of this on-caller easier. Rather than going to AWS console, clicking and figuring out, I might have all the tools exposed here at MCP level, and this might make call to multiple MCP servers, and I have this entire human in the loop that we discussed yesterday to be implemented here. That I just say, do this, it figures out multiple MCP tools, invoke, and your job is done, right? But here it's still human who is using his or her ability to decide what to run if this command is correct and then taking the action. This is not some noob who is doing it. He's a pro. He's a proper on-call engineer who is there to fix this issue as it happened, right? Again, the idea is you can make, if you observe, it's just literally imagination is the limit. You can make any kind of sophistication that you like, but more importantly, the things that I found people not talking about is this sort of stuff, like where there's this notion that MCPs are dead and CLI is everything, etc., etc. But this is a very good example of why MCP makes your life simple. Because if this has access to everything, I can just expose an MCP server over here. I can just say in natural language that do this. It will find out the multiple actions to be taken with a reasoning step. For example, it takes that action, makes my life easier. So your whole job is to make this life easy, like this person's life easy, right? You can make everything as sophisticated as you like, but if you're building this for organization, start very small. Solve one problem at a time. Make sure your entire sanity is intact. Sanity with respect to the commands that is outputting, that is correct. You have this critical loop, and then you enhance, however you would want to like. Right? Awesome. This is some very high level overview of how you would design an incident auto remediation system. Right? That very high level overview. But again, the loop implementation, we have discussed it separately. That's why I skipped it. But on high level part, how the flow should look like is what we discussed. Next week Saturday, evals. But now it will be system design heavy, where we design two systems. First is code reviewer. Everybody is kind of doing that. And self-updating AI documentation system, which identifies a doc drift between your docs and your API where it gets updated. It fixes the drift, gives it a structure, etc., how to design it. I'm designing the same system at Razorpay. So I'll copy paste of it, right? So first we'll discuss evals, right? Where they come in handy. We'll see ways to breach everything and show a demo of that. Then we discuss two systems, which is code reviewer and self-updating AI documentation system. And in this process, we'll look at two prototypes, right? On Sunday, we discuss one big system, which is, I don't know, I still have it count as 0. We'll discuss, so all this stuff I was going to initially cover, all this stuff. but we have kind of covered this with this. This will kind of cover either covered this or we'll cover it in eval's part. So all this has moved to appendix. I'll see what I would want to pull this up over here, but we'll go in depth of this system. This is nothing but Agent Studio that every company is trying to build in some shape and size. We kind of touched upon it when we were discussing this multi-agent loop. I kind of touched upon it today. Right? And your production, this is one thing that I'm trying to brainstorm on, which is about production scenarios, because in first session, what a lot of people resonated with is like people sharing their production stories and like openly saying, hey, this is the situation that I'm facing, what do we do? So it's more of probing. So very concrete examples I'm trying to come up with, in which we'll probe that if this is an AI system, what all things could go wrong? What all things could we do better? So kind of amalgamation of what we discussed with sprinkle of system design to it. And like, because they are like long running systems, so we have to take care of a lot of stuff going down. Right? So this will be, so we might start with natural language workflow engine to start with, and then we'll discuss production scenarios and wartime stories. Right? But pre-reads, keep an eye on it. I'll make sure that I'll send an email as well for that. And very likely I'll be adding some more pre-reads for 6th session that we are having. So for this session, depending on how the curriculum goes or the topics goes that I will be covering. Right? Awesome. But it will be very pragmatic. In any case, whatever stuff I was going to cover will be added in the appendix any which way. So that you can, again, very easy, like it's very classic system design, like cost attribution, open telemetry, regression harness. We kind of touched upon it. Architecture decision frameworks was literally we should do sync or in parallel. It felt very redundant, right? Because we almost always touch in almost all the discussions on what goes sync, what goes async. So I'm like just making sure that I cover the widest range of topics I could possibly cover. Hence a little shaky on the final session, but I'll figure out a way to do it in next couple of days. Right? I'm fully transparent. I want to just optimize for the breadth that I'm trying to cover. Right? Awesome. Folks who want to drop off, feel free to drop off. This is all what I wanted to cover. We'll take questions. We'll start with Kevin. Kevin, go ahead.
Yeah, one thing I wanted to add on this system design is if you want to add, like the postmortems are typically very painful and very time consuming. So towards the end,
yeah, that's a good one. Postmortem generation.
Yeah, is that will help kind of complete the loop.
Oh yeah, yes, very nice. Yeah, so you have all the things. You have correspondence, you have triage, you have memory, you have everything to create your postmortem. Yeah, fair.
Yep.
Yeah, awesome. Thanks, Kevin, for adding that.
Yeah.
Abhishek, go ahead.
Actually, for postmortem, you need a feedback loop as well. If you want postmortem, because AI is not taking all the decisions, there's still a human in the loop.
That is a triage thing. Oh, so you're assuming. So I was assuming all the command execution goes via MCP. So I have a command execution log.
Okay. Like I was assuming the initial thing where we don't execute everything via.
And the user executes it. Okay.
Yeah, and the user executes it.
Okay. But if user is executing, then user should ideally put it in comments that these are the commands I executed. But if that's not happening, this provides you a central place to log all the commands for that issue.
Yeah.
I'll add it. Central command logging. Better. Perfect. And hence now this justifies decision for doing this. That's very important. Okay, Anshul. Oh, sorry. Someone else. I forgot who I pulled in. Sorry.
Yeah. So Arpit, I'm actually on call for the current sprint, and doing your course, I was thinking of something similar. Yeah, a question here. So I was also thinking to integrate it with Jira. Okay. So how to do the chunking? Should it be the Jira ID with the description, but the comments, right? A lot of times the description is a bit vague, and the comments is the place where the answer is, and then we say okay. So how should it be stored, sort of? So the chunking is perfect for me.
Why is chunking a problem? I was suggesting that your Jira correspondence is way too long for it to provide it in one context. I'm suggesting that.
Yes, I'm thinking of that. That could be a scenario, right?
Is that a case? In that case, I would still say summarization is better. Like you would still have like different comments as different things, like different entities in the rows. You would anyway have it. But given its incident, you would likely, like again, 1 million context is anyway too large, right? Like how big is your Jira correspondence?
No, so I was thinking that should it be for one Jira ID the whole comments with the description, but sometimes the comments get so what happens is it goes to one team, then the other
Who is,
team.
oh, okay. Oh no, but this is on call.
Yes.
So on
I was
call
thinking
is more
on
about
call.
incident that happened, right? I'm
Correct,
talking
correct.
at triaging and fixing.
Yes,
After
yes.
that team doing correspondence, it's
Hmm.
there. It's a different problem, right? So that falls under a postmortem thing.
Correct.
Correct. That does not, and again, that is like you initially remediate the issue and then
Mhm.
you work on a long-term fix.
Correct.
Agreed. So like split the two.
Mhm.
Split the two. This is on-call incident remediation.
Mhm.
Correct. Then when your long-term fix comes, there the long-term correspondence comes, and then if you want to create a final summary document of it, then you go step by step. You say, you imagine you start with a blank doc. You say these pick first 10 comments, create a doc. Then
Okay.
pick next 10 comments, update a doc. Next pick 10 next 10 comments, update a doc. So this doc will be ever growing and it will summarize and rewrite a doc every time. Right?
Uh,
So then you create a final summary document. But for your on-call, you don't need that. Your on-call, your correspondence will not, because you're prioritizing fixing of issue. You would take 10 minutes or 15 minutes to fix that issue. You won't wait for multiple tips to add like lengthy stuff during the outage, during that when that incident is happening.
yeah, I was thinking more on the lines of on-call plus support.
So support is long term, right? So there it's like more of a summarization problem. You
Mhm.
create a final summary and actionable. So think of it like Google Meet, Gemini notes that we typically take,
Mhm.
right? Where you have like multiple minutes, it breaks it into 5-minute chunks and keeps updating the doc, extracts the important information, next set of actions, open items, etc., assumptions, etc., and then it creates a final document. Kind of what we discussed with multi-agent today. Same
Mhm.
stuff.
Makes sense. And then another question, the phase 2 that you mentioned in this diagram, right?
Hmm.
A background process that would be running. So are we implying like sort of till the Jira ticket is moved to maybe a done, right? The
Yes.
initial, yeah. So
So that's your
who,
state. So now there your state would be, it cannot be done because done might mean ki my long-term fix is there. So you
yeah.
might say AI triage complete.
Correct.
Something like this. Or out of outage.
Hmm.
It's kind of, we used to have out of outages. It sounded cool, out. That's why out of outage. So we had this out of outage status. So that's why it's very specific to org, right? So it is like I'm out of outage, but my long-term fix is not there. But I still want to track it as an open item. But I just want to mark my outage is not there. It's remediated at this moment. Long-term fix is not yet implemented.
But so what should be the point till it should happen? Like, won't it be too costly for us to run it in background, sort of?
So that depends on your company's bank balance, bro.
Okay.
Don't run if it's costly. Right?
Yeah.
If you think it's helping, so each one of this component, like for example, we discussed 4 or 5 tool calls. If you think these tool calls are helpful, then only you do it. If you think that these agents are helpful, then only you run it. If you think that critic is never helping, imagine so many companies have turned on their AI code reviewer. We as humans have started ignoring them.
Correct.
Correct, Valdia. Nice. Right? At least I have done it. I made a hypothesis. And again, I see many people ignoring AI comments. They're respecting human comments now. Right? Because you see that typical AI slop in them. Right? So, same thing happens if you don't see value with critic, which is like running in background, trying to see it, keep an eye on correspondence, and trying to dig deeper on a more exhaustive task like code, right? Like subsystems, like downstream dependencies. So you split responsibility into kind of real time and non-real time use case, right? Real time, which means during outage, and non-real time is post outage, like post outage remediation or during outage remediation, like not like out of SLA part, like beyond 90 seconds. What do? You do this.
Yeah, it could also be like one for on call and maybe another for support chatbot, something like that.
You are fixated on support, bro.
No.
You're fixated on support. Yes, kind of that.
Yeah.
Yeah,
Another
sure.
thing, Ajit,
And
you mentioned here that when we did some estimations, right? For a FOCO machine, the maximum we could handle is maybe 4 incidents. But here, most of the things that we would be doing is say tool calls and then these sort of things, right? So it is not at all CPU intensive. It would be mostly IO intensive, right? So
Yes.
why that pessimistic of a view in that we took?
As in 4 only, I could do 40.
Yeah.
Okay.
Right.
So why 4 is because there is still some CPU involved.
Correct. Yes.
So you would want to give a dedicated CPU to each incident so that it doesn't. Plus, if you do 500, there is still memory involved. There is still context window that can still bloat up, right? So you don't want that to overwhelm in any way, because if that going down due to undue pressure is more problematic, because it's right now helping your on-call agent, and this is going to work when this is going to work during crisis time. Right? So you have to deal with a lot of pampering.
Okay.
Again, that's just justification. If cost is becoming a factor, you can of course make it 8. I'm just saying, like, you don't want these to go down due to whatever reasons. Right? So you'd add more buffer to this.
Right. Cool. Yep.
Sure.
Thank you.
Thank you. Go ahead, Anshu.
So the first question I have is, like, in general, what I have observed is whenever a service goes down or like there is some issue with that, and there are some upstream and downstream services which get impacted due to that, right? So should we send like for a particular team, what are the open incidents? Should we share it to LLM as well so that it can know, like, oh, this is the related issue
Yes.
which is ongoing,
Yes.
and due
That
to
is what we
this.
discussed. If this is related, then I kill myself quickly. We discussed, right?
Yeah.
During first iteration, you would have the short circuit evaluation, executors. That's how we came from 900 to 225, and then the ways to further reduce it was this one. So if you know that this is related, so that ideally should be our first step. Is this a primary incident or a secondary incident? Kind of vague terminology, but is this
So
primary
how will
incident?
we? So for that as well, like, how will we even know that? Like, so will
Same
there
service,
be
similar issues. Same service at that
but
time, within 2 minutes, you're getting that issue.
it will be different services, right? Like there will be different services which are
No,
getting
then different
impacted.
service, you don't typically do that. You work on it independently. You would typically do the same service, different types of issues that different type of incidents that are being raised. Because you
But
don't know, because you are not sure, like you are not sure that these are related across services.
Right. That's why I was thinking we should share all the active incidents for a particular team if those are low in number, and then like that LLM call
If there is a
can try to
chances for,
identify.
you don't want in this case your LLM taking having a false positive. Oh, sorry, different. It is having a true negative. If it goes in, which is like, hey, I think they're related, but turns out they are not. Right? Problem. Because that is literally kind of suppressing your alert unnecessarily, which someone should have looked at. Right? So, given that this is something that is going to be called during crisis time, just do a deduplication or a grouping within a service.
Okay. And another question is, I have is related to chat, like user is interacting with chat to increase instances and all those things. So it is interacting via MCP, right? So the question is, how is it exactly happening? Like suppose there is a recommendation saying increase 30 instances or increase memory or something like that.
Good example.
Right? So now chat will share this information and user will say, oh, take action on top of that, like increase the instances by 30 or maybe something like that. So now user might have some permissions on MCP using which these instances can be increased, right?
Yes.
But the issue here is, suppose due to some issue, like there will be again another LLM call which will convert our human instruction into tool call or MCP call.
No. Wait. This is the point of difference. So here what you have is, you have an MCP tool defined which changes your number of instance count in an auto-scaling group.
Right.
Get it? So you have this very specific tool definition defined in your thing, that it literally says change instances in an auto-scaling group, which requires an input which is an auto-scaling group, and says what is your final number that you want the number of instances to be.
Right.
So
But
there is this LLM will convert. It will generate the arguments for you that this is the auto-scaling group and this is the desired number of instances.
Right. But there is an issue where LLM can convert that number. Like LLM is also not good, very good with the
Hallucinating.
number,
Yeah,
and
yeah.
then
So that's possible. That is where
yeah.
when it makes a tool call, you can add, if you're unsure, you can add a human in the loop that this is the argument. Do you approve this argument? Or you can change it on the fly and say, "Arey, it was not 25, it was 26, stupid." So you change it to 26 literally and say run. That's the
Yeah,
human
so
in the
there
loop
should
part that
be
you will add it. Yes.
deterministic approach. And how do we ensure that the human which is executing has those? I think that permissions will be sorted because they will already be in some group or something like that. And none of the agent is able to execute those tools.
Yes.
And also, I think there is something related to confidence as well. So in phase one, I think we decided like up to 5 iteration, whatever findings we have, we can return that. And in phase two, we will dig deep into that. So is there any stopping condition or something like that? Like, okay, at this point, uh, I will exit the loop or something like that.
That is
Like,
point of diminishing return.
hmm.
Let's say you see it getting stuck in the loop or it breached SLA. Let's say it breached twice the SLA. Then there is no point running because your on-call is already up and fixing it. Like it's like
Right.
saying ki you won't be able to do it.
Right.
Leave it. Like for example, classic happens when you use a non-Claude model and they keep let it be. You cannot code. Leave it to Claude. Right? Kind of that situation. Now, what is that criteria? That depends on what kind of situations you see, and you keep modifying your behavior. So this like very continuously improving system is what we are trying to build here. We start small, we observe,
Right.
and then we modify. Like what are the criteria? We see stuck in the loop, you take more than this much time. We see some third reason next time failing or not being able to fix it. You keep modifying.
Got it. Thank you.
Sure. Thank you. Sajal, go ahead.
Arpit, in the previous section, like where we were discussing this example of evolving memory, where you had this like I'm going to meet Sam, Sarah, and everything, right? So there we covered like how we're maintaining that memory. I was just trying to understand like, how does the recall happen in that actual conversation where we need to reference that?
That is literally a graph query. So you provide all the relations that you have. You provide your graph schema. So different node types, where you provide your ID format. This is how my node type and node ID looks like. These are the potential relations. That's what Pratik also mentioned, right? That you Pratik, or I think Pratik only tha, which has you cannot have like very verbose. You cannot give a free hand to LLM to come up with relations. So depending on your use case, you would limit the number of relation types that you have. Works as, lives in, etc., etc., etc. Right? You would not let it go berserk with creating different type of strings every time. You would want to limit it as per your use case. So that once you limit the number of relations, now it's easy for you to craft a cipher or a graph query to give you the result that you wanted. What's relevant? Because you know that, for example, who am I meeting tomorrow? You have date node, you have a user node, you have a meeting as relation. You can craft a query that gives you people you are meeting on this date.
So is that query we as a harness creating, or is
No,
that
LLM is creating graph queries.
Correct.
LLM is good
Right,
at creating cipher queries. Yes, LLM is good.
Okay. So we just give it like the context that you have this access to this
So
thing.
you give context like these are my different node types. This is what a node ID looks like. These are the list of relations that I have. And now you create a graph query.
Got it. And just one more question. Before that, you were covering this summarization, right? So I think every 5 steps or every five turns, you were creating a summarized thing. So in that step, in the code, are you like evicting 5 turns?
In eviction, I'm evicting 5. And in summarization, I'm removing those 5 and then adding the summarization.
And that summarization goes as like a role user itself, like saying
role user itself. Okay, hey, this is the summarized output. I want to continue. So it's not assistant, it's user role.
Okay. Thank you.
Sure. Thank you. Suryansh, go ahead.
Yeah, I had the same question as
Perfect.
yeah, one more question. In this diagram, the executor has a connection to this Postgres. Since like, does this also imply it has the it is using the RAG pipeline that we are building on the runbooks and all of that, or no?
Yes. So it's memory plus state management. So I would want, and again, sorry, runbook. Sorry, no, not runbook. I had a tool call for runbook to find relevant runbooks. If you see, I have a fourth one, which is query runbook index. So that tool call goes to VectorDB, gets the relevant runbooks, and adds it to the runbooks.
So that tool basically makes use of the RAG pipelines to get the
Correct. So again, it would might just do, because you would have RAG pipeline which is keeping the vector database updated.
Yeah,
This
right.
tool just queries the vector database.
Okay. Yeah. That's
Now,
it.
why? I'll add just one more point. Why? Because you might look for a run book. So there your prompt is very important. Like what kind of run books to expect? Does this runbook is about like, even do I have a runbook to execute a particular command on my infrastructure because it's an internal tool? So you give them list of runbooks that you have or types of runbooks that you have so that it can create a corresponding query for it to get to fetch a relevant runbook. Right now you can make it as sophisticated, right? You see each one of these direction has its own set of sophistication.
Yeah.
Now you can go as wild as you would like into defining like how to find the most relevant runbook given this as my correspondence.
Right. Okay.
Sure. Thanks, Aryan. We were good.
Yeah, just wanted to share something, no question, but just wanted to share.
Please.
So, in session 1 and 2, I was thinking about the whole chain of thought, and if I could reproduce that, I looked into it. Turned out chain of thought is something else, but then I realized it would form a workflow, right? If I try to mimic it, and I tried doing that, and I started thinking about how long the loop will go and all those things, and it perfectly overlap with the two sessions we have had about the loops in previous session, Ralph and everything, and the memory management. So that sort of helped a lot, even though it was like COT is something different, but trying to mimic it actually helped a lot. So probably that is something people want to try. Yeah.
Thanks. Perfect. We move to Saurabh. Go ahead, Saurabh.
Yeah. Arpit, so you mentioned that we cannot rely on one LLM and one provider, right? So we have to use, but earlier you also mentioned like the output changes from model to model. So how will this? Yes.
So there are, yes, output does change model to model, but there are two ways to do it. Either you have separate agent that is having that crafted query for a particular model. That's what we do. So different prompts for different model. That's what we discussed in first session when Pratik mentioned about prompt registry that you would have, right? So, or a prompt repository that you would have, in which one of the columns could be your model. That this is my prompt template, this is my prompt variables, is meant for this model below or above this particular version. Because we have tested it, it works fine for that, right? So that is one way to do it, where you have different prompts written for different agents, right? Otherwise, if you have the right set of evals, then you say, can I write a one prompt that works for both the models? That's if you'd want to go that way, but then you would want to take, then you need to make sure that you are not degrading output of one just to have just one prompt deal with it. So prompt repository is a better solution to deal with this problem versus writing one prompt that works on all models. If you can, if it's simple enough, all good. But if you say, like I am using Claude versus like Claude and Gemini. Gemini expects very different type of prompts. You have to be very explicit with Gemini and you can be vague with Claude. So what works at one, what doesn't work at other. Worst case, if you're using Claude Agent SDK or any agent SDK, skill files, how are these skill files supported in this agent SDK run loop? Right? Claude Agent SDK supports, but OpenAI SDK doesn't support yet. Skills, the notion of skills. Right?
So we have to
that
keep
changes the game.
prompts for different models at the same time. Like when we are creating an application, or then we have to test it with multiple models and keep it ready.
Yes. Now, how deep you would want to go? You see, now this is also a rabbit hole. Because there is a point of diminishing return where you know that hey, I'm not going to go away from Claude at all, and I'm okay taking up this dependency. That if Claude is down, I'm okay being down because my on-call is anyway going to wake up and fix it. Then why put that effort, right? So
Yeah,
you have to do this benefit analysis.
but again, like going back to the first session where I spoke about, like, you can still use, for example, say Claude or Chat GPT models, right? But they could be different providers in sense when Azure is providing and AWS is providing, right? In that sense, you still have that capability, right? So even if one Azure goes down, so AWS is up, right? So you could still use the same model,
Okay.
but
Fair.
different
Fair.
in that way.
Like Bedrock. Bedrock solves this problem for you. Yeah. Nice.
Correct.
Okay. Pratik,
I
go ahead. Sorry,
uh,
go ahead. Sorry.
I have one question. So you mentioned like if we give the long prompt, then it takes the initial part and the last part. And then today you also mentioned like if we are asking any question and if we will give the same prompt twice, it will actually give the better result and it will enforce it to go through the middle content as well. But is there any other or better way, like alternate way to deal with this? Like how to overcome this?
No, but again, the one thing that I mentioned, which is prompt concurrent with the same prompt again, that just doubles up your input token utilization. Right? Are you okay with that? Right? But
Sometimes.
lost in the middle problem, that's why evals come in very handy. Like how big of a context that you provide that your model respects what is supposed to respect. Right? So which is where even you, for this incident remediation, you would have evals written for it. Like, hey, given these are my sample run books, it should output this string. If it doesn't output, then something's wrong. Right? Then you iterate on that prompt until your eval succeed. If that eval succeeds, then you assume that even there is a loss in the middle problem, it won't affect you. So evals are like unit test. Right? If evals work, you can be very certain, depending on the quality of your evals, of course, you can be fairly certain that this would work just fine.
Okay.
Sure. Thank you. Pratik?
Thank you.
I wanted to go to the initial sections, rolling summarization, hierarchical memory with check memory. आप एक बार उस slide पे जा सकते हो?
हाँ, rolling. Yeah.
Yes. So in this case, when we say rolling summarization, right? So every end turn replace with summary. If you think about it, in cases of like chat applications, let's assume. So what happens in case of chat application is that your API receives one request at a time, right? So someone put in a request, your API gets it, it creates a agent response, sends it back, done. So now every end turn becomes difficult because you might not really have the notion across API.
Lossy पे lossy होगा. Yeah.
Lossy पे lossy होगा. So like this type of rolling summarization can only happen in case of like long running agents or coding agents type of scenarios. So that is one limitation that I see here. The second is in case of hierarchical memory consolidation. My question was like, goes back to how we define the graph and the relationships, how we define the entities here.
So this will be very use case specific. Now here, like for example, if you're doing Google Meet transcription and actionable, then you exactly know that I want to gather evidences of key decisions being made, who said what, next steps that people recommended, a separate section. Right? So it's very use case specific, but that this is not graph. This is literally structured data extracted out of it, which will then be merged because for each 10 minutes I'm processing this gathering, 10 minute processing gathering, 10 minute processing gathering, and then I consolidate it at the end.
Got it. Okay. And weighted memory was, can you go down?
That's the sorry, that's the last one here. Weighted attention.
Oh yeah, this one I think it is there with everything. Like any memory that you're storing has to be weighted by default. Actually,
Not
not
always.
not by default. There are like memories can be categorized into facts and preferences.
Yes. Facts
Preferences
remain
need
as
to
is. Yeah.
facts
New.
stay as is, and
Correct.
preferences are the thing that always have a
Yeah.
weightage that will
Yeah.
go with or have a decay.
Yeah. New
And
Delhi being capital of India cannot have be forgotten. It remains
exactly.
as it's a fact,
Yeah.
not opinion or preference. Yeah.
Correct. So, and then there is also this other type of memory called procedural. You covered it, but you did call it procedural, which is in the system design when we talked about agent remembering what it did such that it can recommend better. That is procedural memory. So
Okay.
it
I
is
never
basically for
knew it had a name. I
yeah.
legit did not know it had a name. Okay.
So like naming convention wise, there are like so there is episodic, there is semantic, there is procedural, and then there is short term.
Okay.
So episodic is basically when you can create a memory and tie it to when it happened, basically. So you can reference back to this was the situation. Semantic is you can take multiple episodes and then extract facts, sort of not facts, but commonly occurring themes around it. So like let's assume a user had 5 conversations with me about booking a hotel, and every single time they have mentioned that they want a hotel with swimming pool. So I can extract that as a preference of the user that they would want to have swimming pool. So that becomes a semantic memory. Within the same conversation, it could also be an episodic memory linked to that conversation. So
Got it.
so semantic is more of an aggregation over multiple episodic memories. So semantic is more powerful in the sense that episodic can happen once and you can forget about it, like it's never mentioned again. But if the same thing is repeated multiple times, it gives me a stronger signal.
Stronger signal.
So that's where episodic comes and plays a role. And then procedural is basically for self-improvement of agents. So what actions agent took, and if it did something wrong, if it
It's
has
like a good behavior
yes,
getting
yes,
reinforced into
reinforced.
it.
Yes.
That is procedure. Oh, we have defined a procedure and I kind of can choose to stick to it. Is a good
Yes.
behavior example. Got
Yes.
it. Remember. Thanks. Akash, good? Oh,
Hi,
long time,
Arpit.
Akash.
So
Hi,
bit off
Akash.
topic.
Mhm.
You created a video on how to build a second brain in Obsidian. So how do you use it now with LLMs?
Gemini. I have credits in Gemini, that's why I use Gemini. But right now, it's still as is. Like nothing changed. But I have now LLM tools that I built that helps me summarize my learnings, my notes, and creates slightly detailed notes and adds to my second brain. That's the only thing that has changed. So I have now my own CLI tool called Brain. That is, I can show a demo. I can show a demo of it. It's very simple tool that I built, which does this. Hey, I have Twitter open. Wait, कुछ अश्लील नहीं है, टेंशन नहीं है. Okay, so this is what the tool looks like. So I do brain add and I can do thought. So all the social media posts that I have, it's a brain add thought, THOUGHT. So here what it does is I can add a thought that I have, which is essentially my social media post. I'm calling all my social media posts as thought, and then it classifies it into stuff and it adds it. So for example, all my thoughts that I see over here are here. So all these are thoughts on AI that I posted. These are literally my social media posts that I wrote. It goes over here. These are my career growth related thoughts that I made. It goes over here. Then I have all my funny posts that I made, goes over here. So every single time when I write something, it is added. It creates tags, wags, everything. I don't use tags for navigation. Just did it because I could. Right now, then all my blogs are here. Thoughts is the major one. All my talks are here. Now what I do is this is one thing. So I have my hard-coded text that I'm adding. I can also do brain add URL. And then what it expects me to pass is a URL. Now this URL could be a website URL. So let's say I go news.hackernews.com and I say fancy word. Let's click on this. Line faltu random. Let me put in far out company. Only scalable design Postgres is drop table. Nice. I'll take this. brainhead URL and I address. So what it does, it goes, fetches the URL and it helps me, it directly adds it that as if I've read it. So where does it add? Basic planet scale, etc., etc. Now I assume, so I call this only when I know I have already learned it, I've already read it. Otherwise, I don't call add. If I have not done it, if I have not read it, so I'll call add URL instead of say brain add run. I say brain learn from this URL. So then what it does is it does the same exact step, but it shows me this information on my terminal for me to learn from it. So for example, you just give it a minute. So this is when most of the stuff I do like this, brain learn, and then I pass in the URL. This URL could be YouTube URL, website URL, whatever. It goes and fetches it. I've now started reading a lot of stuff in Markdown format on my terminal because terminal renders Markdown very beautifully. So let it fetch. Now it fetches, now it processes, it extracts bunch of information that I want, and then it renders it nicely over here. When I call add, it literally adds it to my knowledge base. My knowledge base is here, where I have notes here, notes. So there are all the stuff that I read and notes from it. So my notes and this notes combined goes over here. And this is LLM part. So this is mostly for my recall purposes, right? Because I've already learned it. I already know what this is going to talk about. So I can refer to this and like read again if I want to. That's all, right? Let it process. It will take some time. So now here is the output. So on the left side, this is a literal actual blog post written in Markdown format on my terminal. Because now all of my articles that I'm reading looks the same. Less cognitive overhead. I don't want to remember different styling of different websites and different formatting style of different websites. And on the right side, I see summary. I see key concepts. I see ideas worth writing about, insights, maxims, then analogies and mental models if I want to form. Again, I don't go through all of them, but some of them I go through. But more importantly, I do go through this blog. From this document is what I go through. And this is my learning flow.
Okay. Yeah. Thanks a lot. It's helpful.
But this is the only thing. Now, when I want to hunt for when I was applying at a particular conference and I want to hunt for it. So this brain utility has a settings file. So .brain/config. No, settings is what is called. Rejected topics. Hey, bhai, kidhar gaya? Rejected topics directly. So there are some of the rejected topics that I never want to talk about. So, hey, title. No, these are not rejected topics. Where is my brain setting? Wait. Brain. Sorry, I don't know where that file went. Let me do ls. Hey, then how is it adding? There was supposed to be a file called config.json, which had the topics that I'm interested in. I will need to find where that file is. But brain. So there was a file which had the topics that I'm interested in, so that when I'm reading a topic, it would flag at, hey, this is something that you're not interested in. Let's say CSS. I'm giving an example. They'll just flag that stuff that this article is about CSS. You will never want to read about this article. Move on. Right? So this is what it does. And then I have one more command called read. So what I do is I read books on terminal. So I have 3 books and I maintain state management over here that which book I would want to read, and it resumes from the point. All this state is maintained on S3. I built a database called S4DB to store, and that's where S4DB idea came from. So S4DB. So it's a simple embedded database in Python that helps me. AI slow. That helps me. That does a key value store. That does a key value lookup on S3. All the state goes to S3, and it's an embedded database. I just have to point to bucket and my prefix, and there it stores. So it's a simple key value database, but it helps me put the data and get the data directly from S3. It has a local copy, not the entire copy of it, but if it is cached, it doesn't go to S3 and helps me save some money. So I built this database to power my brain like this. So this brain is all Obsidian, but just the read part of it goes to S3 because I have to store each page of the book separately and to keep track till what page have I read. So that goes to S3. This is what my flow is.
Thanks a lot.
Thanks for asking. I got to revisit. Now I need to find whether setting file went by and my code is still working. I don't know. AI wrote it. So I don't know. So I'll
Is this
check.
utility provided or you have created that? Like, is it kind of alias created or something like that?
Which
Brain
alias?
and
Brain is
brain.
my software.
Okay.
I built that software. Again, I prompted LLM, I prompted Gemini to build a lot of stuff, but I built it for my needs. Yeah, everybody should have their own softwares. I have one for my daughter. Like that is super cool. Super cool. Like I can show you. Very recently I hosted it online. But this is what I do with my daughter. So I built something called as Rumi because my daughter's favorite character is Rumi because Demon Hunters rocks. She's there. Right. So here I have parent login and a child login. So what I do is I have topics for my daughter. This is all Claude and Gemini generated. So I create topics and for each topic I create questions. So my daughter is 5.5. So I create like I'm pushing her to do maths more. And so she does word problem really well now. So I defined what kind of word problems I want to create. So this is like literal prompt. Single variable equation word problem, a simple word problem suitable for a child that can be translated into a one variable linear equation. The equation should involve basic operations. This. It should look like this output, right? Now imagine I have this prompt and what I can do is I can create a notebook. So this is a notebook for UKG for her. I create a new quiz. I select what type of questions I need, how many questions for each type. So let's say I want 7 questions of this and 8 questions of this. And I say generate quiz. So I picked 2 types of questions. It created quiz for me. It will take just 15 questions. It will wrap up quickly. And so this is a parent login. Now I have a child login as well, where she sees active quiz. And then from that quiz, she gives. So she can give quiz on her iPad if she wants to, but she loves using this Blackboard. So I keep telling her questions and she keeps solving it. So this is our bonding moment sort of stuff. Hey, failed to generate. Hey, यार Gemini 2.0 था क्या? अरे यार shit. Very likely Gemini 2.0. Hey, show me अपना. Wait, let me check. Rumi. But I can show a demo on different stuff if I want to. But let's see. Wait, I'll go to different question. So now imagine this is an existing quiz, right? So these are like 10, 12 questions. Now what I can do is I can do print PDF. So it outputs it very nice PDF format. I can take printout, give it to her in the morning. By evening, she is done with the questions. So she gets this motivation, done, and Papa will give me star and sticker and this and that, right? So I do this, and again, this is simple HTML. HTML I did a control P event using JavaScript. Nothing fancy. No PDF parser, nothing. I ask it to output HTML. Again, given I know that I can just do an HTML output and do a control P on it. Again, the idea is you need to know, otherwise LLM will go in very random direction. Right? And then 14 June, na? Kara de, awesome. This is it just created this quiz 14 June today. Right? So now it also has LaTeX. I used to have explanation over here, which is to explain. I could do regenerate. So this way I had, again, I used to store this data on Postgres. It ran a stupid migration, deleted all the data. I had more than 70 quizzes that my daughter solved out of this, which included basic addition, single digit subtraction, double digit addition, 4-digit addition, multiplication, division. Then we started equations, single variable equations, then word problems. Now next up is, now she did word problems with addition. Now addition, subtraction. Now she'll do word problems with multiplication. And then we did science facts out of this, where I asked her to do science questions. So rather than doing this, I ask her speed, distance, time questions. She relates to it. Then we measure diameter of Earth. So she then knows how big the Earth is and how small we are in the universe. So this is my way of doing it. I lost a lot of data out of this, but now I won't because it's DynamoDB. So, and I blocked the API restriction is on deletion. It cannot delete anything. But yeah, this is another tool that I built. This is why I love AI. Like this was not possible. It would have taken me ages to build this.
I have something very similar. I was onboarding to this new team, right? And they gave me 20-25 documents. I was like, fuck this. So I built a onboarding buddy. which basically created milestones for me and has a test for me at end of each milestone to test my
Best.
knowledge.
Onboarding buddy, that's a good one. ये बना था, ये बहुत अच्छा idea है. Wait, like that quiz part is very
Yeah,
interesting. Like, do you
yeah,
really
exactly.
understand it?
Because it has all the corpus of the knowledge. It can ask me the quiz. So I just use it to now. So
Yeah.
every time it generates a MCP, multiple choice questions and answers. And done.
Yes, that's how. And most people don't know what to do with AI. Like they have superpower. You could do so much stuff. But again, people are bad at identifying problems. Like that's my grudge.
Yeah.
People should be good at identifying problems. Like these are the problems worth solving. Like if I just made, I could make it like not open source, but I can just offer it as a service. Login I added because Claude gave me the way. Like because I just a Claude prompt for me to add. I did not even have login. It was there, but now I had to host it because I was running it locally on Docker. So I had to start my computer and then do this. Or like, let me be on cloud so that then I was going to add this one very cool feature, which is my daughter loves when the iPad rings and she has a fact to read because she's just 5.5. So she just started reading and she loves reading facts. So what I have done is I built a pusher channel and I let LM generate a quiz depending on the history doesn't repeat. One illustration, a good text, and that text reads like a YouTube script. So I realized that when I ask Claude to generate a YouTube script, it generates it in a very nice conversational way. And my daughter loves reading it. So I ask it to generate in that way. And with pusher channel, it pushes it, the iPad rings, and she goes running, opens the iPad and reads it. Oh, I literally did it once when I was out in office. I know it was 6:15, so she would be home. When I bajaya, and then my wife said, she's पढ़ रही है इतने happily. I'm like, yes, this is what I wanted. So just making sure she remains curious throughout her life. So चल रहा है. Fine. She's
Did
my
you
neural network. बोलो?
did you so this Rumi app, like did you open it up or is it
Why?
still
Why?
safe?
Why should I open it up? People can build their own software stuff. See, I was going to, the various I was going to, but the effort of opening up, number one. Second, why are you pressurizing your 5-year-old to do this? I don't want to fall into that trap. It's between me and my daughter, right? If she is enjoying word problems, what I learned in 6th standard at the age of 6, I don't care. Right? The day she cries about it, I'll stop doing it. But if she's happy, I see that joy. But people don't understand. Na?
Yeah.
So, like, पीछे like, क्यों कर पाए? But I see in cohort I show, and you folks go and build it. Right? It has done wonders to my daughter. Like she's now has built that intuition, like that love for math, that love for science. So
Yeah, the other thing I'm struggling with is screen time with my kids. They're 4, right? I think you know. And when did you introduce screen time?
1-year-old.
With your daughter?
I gave her phone.
Okay, but
I gave her phone. Why? I'll tell you my reasoning behind it. Right? My reasoning behind it is when my parents were forcing me to not watch TV, I used to watch it more. The moment they stopped forcing, the moment they said go watch it, I got bored of watching it. So now I'm seeing the same trait in my daughter because what I realized, my daughter is carbon copy of me in terms of behavior. So what worked for me is working for her. So I literally gave her that, Jake, Joe, whatever you want to watch. She gets bored after 15 minutes and she comes with, Papa, let's solve maths. Sometimes she's in mood, she watches for 2 hours. But after that watching for 2 hours, when I ask her, hey, chala, let's study. Well, ha, Papa, I was anyway getting bored, let's study. So she might need a trigger point. But because that's exactly how I behaved when I was a kid, I'm just using the positive and negative reinforcement that I received into positive reinforcement for my daughter, like finding ways to do it.
I guess
screen time, there is no restriction from my side on her.
Yeah, as long as she's not, I guess if she herself is getting bored and wants to do, then it works out.
But even if you look at it, I look at it this way, that watching TV or having a screen time is a positive reinforcement for her, given if she's solving 25 to 40 questions a day.
Yeah, but again, depends like what type of screen time, right? I mean, is it just like TikTok videos which are just like short
Oh,
form,
no,
or they are
no
not
short
actually
form.
like solving?
YouTube.
Right, actually. Okay.
YouTube. She was YouTube 6, 7, all of that stuff. This Rumi is what? The K-pop Demon Hunter, bro. I have memorized all the K-pop Demon Hunter songs now. Like, I get excited when I see someone playing Demon Hunters. Like, hey, Ruby, Ruby. I like Zoe more, but yeah, Ruby, Ruby. I'll just start screaming. And like, why that? Also, one more reason. Sorry for this parenting pep talk, but one more reason. That when she sees me being interested, she is so proud of it that my dad is interested in like girl stories.
Hmm.
And like every time that song plays Doom 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 Wala, how it's done, she comes running to me and says, Papa, your favorite song is here. And like that is important. Like for me,
Yeah.
I can watch all sorts of brain rot stuff that she is watching, like Mikey and JJ and Minecraft videos and all, just for that one moment that I get every day. चलता है देख ले भाई तू देख ले मैं खुश हूँ कुछ फर्क नहीं है but again she does 25 to 40 questions a day. Her maximum is 125 in a day. She was in a fab mood that day. 125 questions. She studied for 4.5 hours non-stop. Again, this was like addition subtraction, but all in her head. She was in that mood. I was giving like single digit, double digit addition and subtraction. Subtraction without borrow, but addition with carry. And she was doing it in her head. She was in that zone that day. So मजा आया था उस दिन. I have like 50 photos I clicked of her that day because she was on fire. 4.5, 5 hours non-stop we studied. This entire blackboard became white that day. Because every time she was storing 5, Papa, give me a star. Every time she stored 5, Papa, give me a star. Give me a star. I made stars that day. Full stars. My
Yeah, I
best
kind of
investment.
applied this. Yeah, some of your theory. It's helping with math.
Best 600 rupees ever spent. Ever. Best 600 rupees. The day she was born, so the day we moved over here, within a week I ordered this wall sticker that converts a wall into a blackboard. 2 stickers, stuck it in my room. Bas, best decision ever. बहुत मजा आता है. We do so much fun on that whiteboard, that blackboard. Yes. But the way I also put it is I'm just raising my co-founder. She's my neural network. I'm training her. And I'm training her to be my co-founder in the future. Like what I wished I had as a co-founder, or how I would want to be a founder, because education system I have zero trust. So then what do? Raising a co-founder. Fallback plan, she'll become an engineer like me. But best case scenario, after 10, start up with me. तब तक तो अपना भी पैसा बन जाएगा. कुछ तो कर लेंगे. तो हाँ, experiment है. So I got very much inspired by Polgar, if you have read about him. Polgar was chess grandmaster and he had a belief that geniuses are not born, they are made. He had 3 daughters. तीनों को grandmaster बनाया.
What is Polgar?
Polgar is a surname of a person who was a grandmaster, chess grandmaster.
Oh.
So Polgar. I read about him 8 or 9 years ago. And it stayed with me. Again, it's not a forcing function for me, but it stayed with me. That geniuses are not born, they are made. And like, let me try. Like, if my daughter reciprocates, then why not? I'm trying. I'll see where it goes. It's an experiment. Also, she also recorded 2 YouTube videos. She sees me doing videos. She said, Papa, I also want to do it. Because she sees whenever I step out, 1 or 2 people come and me, hey, Arpit, big fan, this, that, they click photo. She gets jealous. And she asks me, Papa, how come everybody comes to you and not Mama? Your Papa's famous. Papa, I also want to become famous when I am 20. What do I do? Well, Papa makes YouTube videos. Papa, can I make YouTube videos? We have a video recorded of her where she was explaining prism effect. She was explaining that entire water cycle thing. She can explain prism effect really well. Like she kind of mugged it up initially, but now she can understand it, like why that light splits and how it splits, and light has wavelengths. I literally had a demo of sound is physical sort of stuff. So she tries to explain it, and then how plants grow, like that entire thing. We have three videos recorded, and like I still don't want to post it, but she gets happy when I play it for her. She thinks it's live on the internet. Wala, wait for 2 years, people will come to greet you as well. So that's an incentive. Wala, वो ये वो भी stupid है, मैं भी stupid हूँ, but it's working out. You do random stuff. Again, I see that same trait that are there in me. Like she doesn't look like me, but what traits है उसमें मेरे वाले. So what worked for me, that external validation and that lack of confidence and सब copy है, behavior में copy है पूरी. So I'm happy one way, of course, but chalo, awesome. Sorry, this always happens. But use LLM to build stuff, like find problems worth solving that you think is problematic, like onboarding buddy, Pratik built, do it. When you become parent or if you're a parent, try to build stuff like this and like just get your kid excited. And one more thing. I made her call AI as AI auntie. And then she gets that personal attachment with AI auntie. And she vibes code sometimes. I ask her, what do you want it to build? So I let her imagination go wild. When that Gemini Nano Banana came and they gave free to everyone, I made her imagine what you want to imagine. So she imagined, Papa, what if there is an animal with body like lion and like face like giraffe? Well, ask AI Andy to build it. Papa, this is how it would look. Well, wait, now I'll show you something. What if there's an animal called Torsquito, which is a tortoise and a mosquito's combination? And then she started imitating me. Then she started merging multiple animals. And I had to nudge him. Here is ज़्यादा positive reinforcement हो गया. Then I gave a different example. So then it went in that direction. And then I made her vibe code an app. I'm like, what kind of game you'd want to play? Then she said, Papa, I want to play a game where I can like jump and swim both. I'm like, कहाँ बनाऊँ? And I say, ask AI Aunty to build it. Claude Opus 4 point whatever. नहीं, Claude Opus. Opus आया था. हाँ, Opus था. I just bought Claude subscription that day. Ask it to build. Papa, can AI Aunty do this? Well, yeah, try it. I don't know. She asked. And the best part is AI understands child tone. Like that was surprising. And it does a very good job at it. And then she understood what to say and what not to say. During second iteration, it became much better. So she's like prompt engineer now. She writes better prompts. Hey, make it look beautiful. Not round, square I want. ऐसा बोलते फिर AI करता है उसको. I am giving full exposure to tech. Like, I'm not restraining. She uses calculator. इधर रखा हुआ calculator टेबल बेड पे पड़ा हुआ है. हाँ, बेड पे पड़ा हुआ है. So, like full scientific calculator. Like, I don't want her to do mental maths. Like division. डालना भाई 24 divided by 6 कर ले. Like, she knows 6 4 are 24. But why waste time? Right? Because if she can articulate text to equations, good enough. बाद में तो कंप्यूटर है ना. अब now the AI is there, we are saying we are all prompt engineers. The whole thing is intuition and problem solving. So I'm focusing on that. सबका थीसिस है, सबका थीसिस है, सब भाग रहे इधर से उधर. But हाँ, that's the situation. चलो, awesome. Anything, anyone? सबको नींद आ रही है ना? चलो सो जाओ. Go ahead. भाग गए 4 लोग. चलो, awesome. Thanks a ton, folks.
Thank you.
Chalo.
Bye.
Thank you.
Bye bye. See you folks next week. I'll share the periods and post it in some time. Chalo. Bye bye.